mathematical model. I mean, I didn't see any other mathematical model to contest that. All I saw was someone not actively engaging with it and trying to sidestep.
It's just, and the reason for that is
like word salad. That's what I was hearing.
The reason for that
nobody's obliged to interact with anything that somebody proposes. Nobody's obliged to do that.
What does that mean? You're having a conversation. Yeah,
real quick, moderation. We're just trying to. Zynak was trying to get in. I don't know if you can hear him, Napalm, but Zynak was. You went over him, but Zynak, go ahead.
Yeah, it's just short. The reason why I'm disinterested is because it's simply just a mathematical model
that represents reality.
But you can present. Dude.
Yeah, great. I'm glad he said that with the representation bit, but here's the thing. A representation is not concreteness. So because you can draw something like a map doesn't mean that I buy the map for the territory.
That's a false equivalence. He's talking about trigonometry, not about drawing a map.
Let me get on.
Well, let me clear that up. Sorry, can I clear that up as well?
Bad analogy.
Sure, and I can go afterward.
Yeah, right. Please do that. So, okay, yes, he's drawing the map with the trigonometry. At least he claims to be. But the problem is when he says that that is like the map. You have now the map, and this is reality. This is where the problem comes in, and that's just the basic mistaking. Okay,
I never said that. What I said is that we have a map that is accurate enough for our purposes. Our goal is to construct the most accurate map of reality as possible, and trigonometry is a damn good tool in which we can do that.
So I hear you imagine that you have come to such capacities, but it's simply just a very, very big claim.
What do you mean capacities?
You're making a claim of having God's eye view or access to the world of which we live in. This claim creates delusions of grandeur. And this kind of
are you saying I'm plugged into the Matrix? Is that where this is going?
Hey, what I'm saying is that making such a huge claim naturally leads to delusions of grandeur, and it makes one feel in a very, very privileged position.
No, I'm privileged to telescopes, my guy. I don't feel as though I am. Let me be clear about something, because I've heard this shit so many times. I don't think I'm better than anybody. I don't think I'm smarter than anybody. I don't think any of that. I simply have access to telescopes with the necessary resolution capabilities.
But Reds, he's saying that because he doesn't want to engage with the math. Like if you're actually
hold on, real quick.
Dispute that, why don't you bring your own model?
If you can hear me real quick, I think all Zynak was saying is just because math can represent reality, it can also be used to misrepresent reality. Is that what you're saying, Zynak?
Yeah. That is a good implication, yes.
All right, good. Let me address that. The way that it's used to misrepresent reality is to get the values purposefully incorrect. So that would be like a flaw in the methodology, for example. So you would have to tell me, okay, given the methodology that I presented, where is the flaw in the methodology that would result in wrong data points?
Which is where you could be starting with assumptions.
You could be starting with assumptions. If there's any assumptions about radius or any kind of things that are assumed within the math, doesn't mean the math's not correct. It just means that there's assumptions baked in that you're taking for granted or assuming.
Well, it's a hypothesis. Correct. It's not an assumption. It's not always an assumption.
Let me be clear. Let me clear, and I understand this is a spoiler alert for this entire video. You should just watch it. There are no assumptions.
So you think? It sounds rather
no radius
people
assumptions.
Who know how to do science that you are naive to the assumptions or presuppositions that you're making.
There is no assumptions in this calculation, okay? When we did the math, we went through we even personally verified Kepler's third law. We could have simply taken that for granted, and we didn't. We did that for a reason. It's because we know that if there was any data point that we just glossed over or skipped over or whatever, you guys would harp on that and be like, well, how do you know for sure? That's just an assumption. Therefore, I can just reject this entire measurement outright. We called that literally years ago. So no, there are no assumptions within this measurement. And explicitly for the Mars distance measurement, every data point was gathered on our own. We used our own equipment to gather that data point.
Wow, it's like it doesn't track. So, hey man.
Why doesn't it?
Just please go into detail. What goes into the math, etc., etc. Like what exactly are you doing? Like from the grounds up. Like if you take me. Just imagine I'm stupid as hell, grant me that, I guess.
Okay, I'm there.
And then, I hear. And then just, take the baby steps. Maybe I'm a fourth grader or something, the usual. And then build it from, this is not a question, this is an invitation. So, please don't make more category errors. But anyhow, Just take me
All right,
in the baby
you
steps
had it
from
for a
the
second, and then you became a smug asshole again. Go ahead.
Yeah, exactly.
Yeah, because
Okay,
you
so in
came
order
in
to
with
do that,
smug
you'll have to
commentary.
look at the
Just
screen.
take me through it from the grounds up and show me how it's done.
No
Simple as
problem. Okay, so
And
let's go
take
ahead.
it very slow so we can see whenever the presupposition comes into play, and I'll name it for you. Okay?
All right,
Be
cool.
open
So
to be
we're going to
stopped.
go through this step. There could be one such combination of motion that causes one of those stars to be ejected. It's similar to a gravity cyst, and you're stealing momentum from one star, which transfers it to the other star, and that extra momentum is enough to kick it out of the system.
You know, Rez, I had to go back and re-listen to something I posted with you explaining this to Locksmith the other day, and you said you measured the radius of the Earth at the beginning of the video. Like you figured out, like you measured the radius. How did you measure the radius of Earth?
That was one of the things that we're going to go over when the guy comes back from taking a piss.
Just so you know who you're dealing with, though, Red, earlier before you came here, Siniak was talking about how 4-month-olds have existential crises. And even the flat earthers in here who will literally believe anything.
I'll say this without spoiling anything. Yes, the size of the Earth is actually necessary in order to find the distance to Mars. That is 100% the case. So you're on the right track there.
Yeah, calculations are measurements, right?
You can just assume
that, right?
Yeah, so then that's your assumption. So that's your assumption. One of them.
But Red, you can assume a flat baseline and not try to take the chord length across.
Let me make this clear because there was two questions there. I will answer that question, but just be clear. Gio, it's not an assumption. It was a measurement. That was not an assumption that we made. We actually measured the radius of the Earth. And as far as assuming a flat Earth, we actually did that in the video in which we made that measurement. If you were to assume that the Earth was flat and you applied our measurements to a flat Earth, you would actually get contradictory answers as to the location of the North Celestial Pole. Making the measurement from Florida like we did, and using the values that we got on a flat Earth, you would actually place the North Celestial Pole just beyond Canada, just beyond the border of Canada, right by Vermont. And obviously, the North Celestial Pole is not in Vermont. So you would get contradictory answers if you assume the flat Earth.
Wasn't the diameter of the Earth used to calculate the distance to Mars, if my memory serves me correct?
That is correct.
Calculate. Yeah, calculate.
And how did you get that? Wouldn't that be part of your assumption there?
No, because it was measured, and I'm going to go over that measurement, but I have to wait for the guy to come back from taking a piss.
But before you do that, calculations aren't measurements. You agree with that at least?
No, calculations most certainly can be measurements.
No reason to continue then, because it's still an assumption if it's calculated.
No, it's not an assumption, it's a measurement.
Well, that's where everybody's going to leave you. We're just going to let you go on your way because we don't believe that calculations are measurements.
No, that's fine. You can cope, but the other guy is still asking the question, and I still wish to provide him an answer.
You can call it coping, or you can call it you coping by saying it is. You know, just assuming
whatever you have
and
to do
declaring something doesn't make it so. Whatever you need to do to make your assumptions actually work for you. Yeah, go ahead.
Whatever you have to do. If trigonometry working triggers you, that's not my problem. Anyway, is the guy back?
It appears we found the first assumption, knowing the diameter of the Earth.
Well, it's not an assumption, as I said. Is the guy back from taking a piss yet?
It's one hell of a long leak.
Entire thing, every 763 degrees. So we have angle A, we have angle M, we have the length of our baseline, which means we can find the distance to Mars, and there it is. Notice that throughout this entire thing, every input in every equation was gathered with our own equipment and with our own work.
But the equation existed priorly, so you applied an already existing framework.
Trig. Yes, I applied that which works, which is trig. That's not wrong.
So your baseline, you cut it assuming through the Earth, you said, right?
No, it's not assuming through the Earth. The baseline is through the Earth, and we measured that baseline by finding angle E.
By finding angle E?
Yes, angle E in this diagram. Are you seeing the diagram?
It's the central angle.
It's the big blue angle labeled E in the image.
In the middle of the circle.
Right. So you're assuming that you know the center of said Earth.
No, that was an assumption as mentioned previously. We actually measured the angle. I just went over how we did that.
Wait, what? Did y'all not see the first 4 minutes?
No, I saw it. I was listening.
Okay,
that's where he said they took an angle to Polaris, and then they drove 3 miles away and took another angle to Polaris, and
that was this controller part right here. So we use the altitude motors of the telescope, which gives us very, very accurate angle measurements. Remember this part?
Yeah. What if you measured perspective hemisphere of the celestial lights to your personal location, and that celestial hemisphere has a radius of 3,900 67 miles.
Okay.
And you drove along a flat plane, but you measured to your perspective hemisphere that travels with you because all light goes to a central point, no matter where you're gathering it from, right? So your perspective is always going to draw light directly into a central point. Thus, it can be measured by angles. So you're measuring angles to your perspective dome across a flat stationary plane. So if those angles change due to your location, central location, which is a celestial dome with a hemisphere of 3,967 miles, what would be the difference between that and what you're claiming you're measuring here?
I'm going to be completely honest with you. It sounds like you're bringing up Jaronism's already debunked personal.
I don't care what you think I am or am not bringing
assuming
up,
that that's what you're going
out
on.
somebody else's
If
name.
we
How
look
about
at
you
the
just answer
personal
my
atmospheric
question?
dome thing, then it actually points to it being a local phenomenon. Well, if that was the case, we wouldn't have gotten a parallax measurement when I was in Colorado and my partner was in Florida. If it's a local phenomenon, we wouldn't have gotten a measurement.
So you're saying that parallax is not possible due to perspective?
Perspective is alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object, g is the actual size of the object, and r is the distance to the object. What about that equation says locality?
But you're making the assumption that
There was no
is
assumption in
no,
that formula.
you're
There
making the
is.
assumption that
What was the
locality
assumption in
has
that
nothing
formula?
to do with the measurement. That go for it.
The entire experiment is first and foremost built upon the presupposition that the scene, the world, can be geometrized. So, you know,
This is coming from someone that agreed that mathematics was a fine representation of reality, and that the mathematical relationships are also a fine representation of reality. Now, of course, you decided to not allow that any further when I brought up pi, sine, cosine, and stuff like that, but I think we all know why you decided to stop it there.
No, you're coping. You're trying to
no, I'm calling out. I'm calling out. I'm
onto
calling out
me.
your dishonesty for all.
No, I called you out, and then you had to try and shift the burden of proof. Or sorry,
yeah, by using your own
shift it
words
onto
against
me.
you. It's a bitch, isn't it?
Not at all.
Amazing how I can remember what you say.
You just don't want to be captured because I pointed out the obvious.
You guys are going.
Like you have been captured just now.
You guys are kind of going.
Gio, can you moderate, please? Thank you.
Yeah, well, it's kind of a meta loop right now. It went to that. Can we? What Napalm had asked about, can we get to the conclusion of that? Because I just wanted to say, if you have like a planetarium, basically replicates what the sky looks like, and a planetarium is designed where if you're in the center of it, that's how it's supposed to work. If you walk around the room, it kind of throws it because you're getting a different angle because you always see from a central point, like Napalm was saying too. So if you're in the center of a planetarium, you can pull up the stars for any position you want. So if someone's in Florida, someone's in Colorado, you could pull up in a planetarium exactly what the stars look like for your position in Florida. Or you could do this with stellarium, other things too, and then you can pull that up for what it looks like in Colorado. So they're basically two hemispherical views of the sky, a viewpoint of the sky, and they're both, whether it is a hemisphere up there, what the shape is up there. Not really going off that, or trying to talk about that, but more just a planetarium replicates that, and we know that we have to make a planetarium domed, a hemispherical structure, in order to represent the stars. It doesn't work if you just have a flat ceiling, not in the right way. So if you have someone in Florida, someone in Colorado, and you're both, whatever the sky is, you are viewing some kind of a hemispherical region of stars, which is why we can replicate it on a small scale. So with that being the case, I think like what Napalm was alluding to, or what I thought he was in a sense, is how have you been able to isolate that this radius value and the phenomenon here is not related to the sky being in a hemispherical region around you and being a function of the sky rather than having something to do with the actual Earth being a certain shape and a certain radius of a sphere?
Because again, as I said multiple times in this very space, I believe I even said it to you directly, Gio. If not, I apologize, but let me say it one more time. If you put a telescope mount inside of a planetarium and we do the exact same thing, just smaller, instead of me doing 3 miles, I would do 3 steps, making things to scale and whatnot, I would be able to tell you with certainty the shape of the ground. That's not a guess. That's not a hope. That is me saying for a fact, you put me in a planetarium. No, you put me in a planetarium with a telescope. I can tell you for certain what the shape of the floor is. If you give me enough time, I'll even be able to tell you where the steps are inside the planetarium.
What shape is the floor? What shape is the floor?
Are you talking about moving around the planetarium? So I specifically said that's not valid. Like a planetarium pulls up the stars from the central point of the planetarium, meaning your latitude, longitude. If you start walking around the planetarium, like, walking to the walls and stuff, like I said, that throws it off. So if you're saying
that's what we did in this observation.
That's why you don't understand it, bro.
What you would have done. What you would have done in a planetarium to replicate what you guys did would be this. Let's say you have the planetarium. Let's say you can punch in your computer screen any latitude, longitude, or essentially right ascension declination in the sky. But lat long as transferred down to the ground. You could type in any lat long, and then let's say within seconds, boom, now you have the stars that are of that lat long. And then now you type in a different one, boom, you get a slightly different set of stars when you change the planetarium settings. So what would be equivalent to what you guys did would be you'd have the lat long for the Florida position, and then the lat long for the Colorado position, and then you would put the first one in Florida, boom, boom, pull it up. And then you could then put the ones for Colorado and then pull that up. So you're in the center of the planetarium both times. You're just pulling up the views for those two positions.
Yeah, but the center of the planetarium, the only way for the center of the planetarium to know where we are is by virtue of us actually moving. So that means that this planetarium would have to be latitude-based, but we're not saying that it's latitude-based in reality. It just appears as though it's such. Then I would simply ask a question, what's making it appear that way if not the geometry of our planet and its relation to the cosmos?
Because it's the geometry of the perspective. Because the center of the planetary, why don't you let me finish, and then maybe you'll understand the very basic concept that I'm about to lay out to you. Because you're making the assumption, because you're making the assumption that moving around that planetarium with your telescope, you'd be able to figure out what the shape of the floor is. But what you don't understand is that the perspective of the stars, anywhere that you would move, the center of the planetarium would move to directly above you, and the stars would make adjustments on the ceiling.
Okay, so
that's
I was
what
correct.
You don't understand.
Okay, so I was correct. You actually don't know what you're talking about. It's good to have confirmation, though. You're correct. So
you said absolutely nothing just by saying I don't know what I'm talking about.
Hang on. Again, if you want to know why you're wrong, you need to stop talking so I can educate you on this. Maybe you'll learn something. So anyway, as I was saying, in order for the planetarium to give me that sort of groundwork, it would have to do three things. One, it would have to reveal itself as not a planetarium. Planetariums are not perfect. They're skewed. And as a result of them being skewed, they're a good representation of reality, but they're not a perfect representation of reality. They will never be a perfect representation of reality. You would need a pretty big dome, and unfortunately, we have construction limits on that. Number two, the planetarium would have to be large enough to occupy different latitudes, because we would actually have to drive within this damn thing. That would make the situation worse. It would make the skewing worse. And number three, hang on. Again, in order to learn, you need to actually listen. So again, number three. In order for perspective to be a thing, you would actually have to apply the principles of perspective. Again, the actual law of perspective is alpha equals 2 times the arctan of g over 2r. Alpha is the angular size of the object, g is the actual size of the object, r is the distance to the object. In short, good sir, in short, astrometry would not work with personal atmospheric domes because the skewing would be such that we could not even get a measurement. Let me say that again to make sure it's clear. If we were to apply astrometry to a personal atmospheric dome, the skewing would be so bad we wouldn't even get a measurement. So I reject this possibility outright.
So when you said that you would be driving, so when you say you would be driving around inside of the dome, is that dome fixed that you're talking about when you're making these measurements and you're driving around to different distances inside of it?
Yeah, I would have to, wouldn't it? Is the dome not fixed?
See, yeah, exactly. You don't understand it. Like I said before you went on your tirade to educate me in the concept that you don't even comprehend. Good job, good sir.
So in order for him, so the dome magically moves. Okay, got it. I understand why I reject your assertion. Even more so.
Hey, I'll tell you why it's not magic. Yeah, I will. You know why it's not magic? Yeah, I will. So you know why it's not magic? You know why it's not magic?
Perspective.
Yeah. So when you're taking an observation from a singular point,
which we didn't do, go ahead.
You didn't take an observation from a single point?
No, we took it from 2 points, multiple points. If you had paid attention, you would have known that.
But each one of those would be singular.
Go ahead.
Each one of those would be singular, right?
Except there's multiple, and hence not singular, dumbass.
So when you're taking the measurement angle, you have one measurement angle, and then you have another measurement angle. But each one of those is to a singular point, meaning everything around you that you're observing with your little telescope theodolite as you're making angles, the center point of all the angles that you are making has to be the observable point. The point of observation, meaning you can swing that telescope around in 360 degrees laterally, or you can swing it around 360 degrees over your head to your feet and any other direction you want to. But if you had a marker on the outside of that telescope, as you would run it around and around and around and around, let's say you take a time lapse of it and there's a little light on the end of your telescope. As you're running that around, it's always going to make a sphere, right? And at the center of that sphere would be the point in which you're making that observation, meaning that singular point of observation is always going to draw all of the angles to that center point, the observation point. So it's a singular point of perspective. Now, if you move away from where you're taking that observation to another point, you can do the same thing, but all light and all angles are being drawn to another point.
So again, in this weird reality where singular doesn't really mean singular to you, let me explain one more time. The singular/non-singular points, or the singular/non-singular measurement, was made simultaneously from two different locations, dumbass. Which means that your singular narrative doesn't actually work. It must actually be applied to the singular narrative, which
you still don't even get it, dude.
From the singular narrative that you originally said. So once again,
when you're taking an angle,
in order for you to be educated, you need to listen. Again, so what you're saying is that what you're saying is that the personal atmospheric dome,
it's hilarious, dude. He doesn't even understand.
Can you handle that, man? Because this is just straight up
somehow moves in a particular way to match the globe so perfectly, because that's what it needs to do in order for your bullshit story to have any hope of surviving. Except we have two problems with that. One, we have no evidence that this personal atmospheric dome exists. Two, you didn't address the skewing problem. And three, this dome would have to be absolutely fucking massive.
In order to
have fucking what's his name in here? If this is going to be the same shit all over, man, this is just stupid.
How come nobody?
Yeah, this is funny because when you're taking your angle measurement, right,
like personal atmospheric dome,
the vertex, right, of your angle,
and that way I can sleep easy at night knowing that I can reject Red's Rhetoric's completely valid measurements and say it doesn't work.
So when you're taking a measurement, you have, let's call it what, the vertex, right? Whatever, where you're taking that angle measurement.
What do you define as the vertex?
I don't know. The corner of the angle. The corner of the angle. I don't know what. What would you call that?
When you use that word, what do you mean? I don't know. We're off to a great fucking start, guys.
So what is it then?
You tell me. You're the one using the word.
So you don't know what a vertex is, but you're gonna educate
No, I'm asking you what you mean when you use the word.
The corner point of an angle.
So if you don't know the word that you're using, what the fuck are we doing here?
A corner point of a single angle. Do you disagree with that or not?
I don't care how you define it. That's why I was asking.
Oh, you
for
don't
the definition.
care. You don't know. You're just trying to act like I'm stupid, but you don't know what I'm talking about.
Well, you're the one that you didn't know the definition of your own words, so you tell me.
I just laid it out for you, buddy. Is it incorrect?
Cool, I accept your definition. Now move on.
Okay, cool. So when you take a singular angle, you have one vertex. So when you have two vertex, you're creating multiple angles, right? You can create the triangle if you have a second vertex, but you'd have to have somebody at that specific point. That is my whole point when I'm saying you have a singular, the vertex is always going to draw all points of light to it, effectively creating your perspective, meaning you can't just meld the two together, which is why you didn't understand the concept of you would say, we'll drive around inside the dome and then we'll just make different measurements. That's why you didn't understand the concept. Because you don't understand. Dude, first of all, you're not even paying attention to the conversation. It's a hypothetical, right?
Not based on reality.
We talk about a planetarium? Oh, so we weren't talking about a planetarium.
No, you're talking about a personal atmospheric dome that Jeranism now rejects, which is where you got it from, by the way.
Did I say a personal atmospheric dome based on Jeranism?
Yes, actually, via your definition, that's exactly what the fuck you're talking about. Don't try to gaslight me, dude. You think this is my first rodeo?
He's not here.
Dude, I never even brought him up. And first of all, I'm saying it's based on your singular perspective. I didn't say anything about a personal atmospheric dome. I'm saying that you see and you have a limitation to your vision that just so happens to be 3,950
we can see further
miles.
No, we can see further than that.
No, that's your perspective distance.
No, perspective is.
I didn't say you couldn't see further than that. Did I say you couldn't see further than that?
Is the actual size of the object.
Did I say you couldn't see further than that?
The law of perspective does not state that as an object gets further away from you, it will eventually arbitrarily just disappear. What it says is that the available resolution of your eye will eventually become insufficient to make out the object, but if you have enough angular size to work with and enough brightness to work with, you will be able to see it at any distance.
Nobody said that it disappeared, so why are you straw manning me? I can sit here and talk through you if you're just going to straw man me, because I never said any of that. Your inability to understand the simple concept is not my problem. Just because you don't understand it, let me educate you on this then, right? Because you didn't even understand what a vertex was. So somebody that doesn't understand what a vertex is going to try to educate me?
Yeah, you didn't know the definition of the word 5 seconds ago, so please.
I literally gave you whatever my personal definition is. I can look it up.
Definition, which is why I asked
you want me to look it up.
On it.
Here, I'll look it up.
You go right ahead, my guy.
What is a vertex? Let me give you the actual definition.
How about Geo ask the question? I like talking to Geo. At least I can actually talk to him.
Angle vertex, the corner point of an angle. Mirror vertex, the center point we just discussed. Interesting. Parabola vertex, turning point of a curve. So I was referring to an angle vertex, the corner point of an angle.
Just call that angles.
The corner point of an angle. The singular.
Otherwise known as an angle, which is at a corner by definition, dumbass.
Yeah, so if I move away from that and I take another angle,
that would be another angle. We would just call that angle.
Exactly.
We would call
it's
that
another
angle A and angle B.
You're trying to say it's all the same perspective.
It's all angle A and angle
Dumbass.
B. So you saying vertex to make yourself sound more intelligent isn't really going to work for everyone here. I'm sorry.
I didn't use it to sound more intelligent.
I mean you could try. You might guess.
Like, what the fuck is this, man?
Dude, like
right
vertex is some sort of like
I've been trying to point this out since forever. This guy is only here to attempt make you guys sound like lunatics because he gets off of it or something.
But the funny thing is, he's the one that sounds like a lunatic. He does. I mean, he's spiraling and he's flailing all over the place, and he has to misrepresent what I'm trying to say.
I'm misrepresenting by actually asking what the definition of the words he's using.
Right, can we just,
no, you're only here to tone police.
Reset? Hold on. Can we possibly reset? And can we also try not to do the ad homs and stuff because that just causes more like intensity. That's kind of distracts from the combo. Okay, can we reset for a minute? Hold on. Napalm, when you're talking about vertex, here's my question. Okay, I'm gonna post this in the chat. Reds, if you could take a quick look at this. I don't even know where I got this from, but it's obviously like seems like an old book of some sort. But it says here, within his eye formed atmospheric tent, and then it says. At a man in his tent must be, he through its bounds can't enter. No matter if on earth or sea, he's in his own eye's center. Wherever he moves, his tent moves too, and then he gets a different view. So this is sort of what's being referred to, like the way a planetarium, you can change the position of the stars on the ceiling by changing that, through the computer, through the projection system. You're getting, different views of different latitude and longitude. That little image I posted is just sort of shows that concept. And, when you have, and the way it describes it, like it's in the center of your eye, basically, is what it's kind of saying, from your own eyes center. The kind of idea that wherever you move, it's right from your eye out. And then you're going out, and then it's calling it a tent in this case. So this book, whatever this is from, I can do a reverse image search, which I've been intending to do, but I haven't done it. But this is probably way before Jeranism was even born. So this conversation has nothing to do with Jeranism. That was a phrase I think that actually the guys on Globebusters had come up with. I'm not even sure Jaren came up with that, but it doesn't matter the naming of that. The point is, this phenomenon has been talked about throughout all of history. It's not like a new thing, and it's been talked about in terms of how we see, and that's what a planetarium replicates. So, but Napalm, by vertex, did you mean like the center of what, like an atmospheric tent? Is that what you're referring to? With the vertex thing, I wanted to ask that too, but yeah, I just wanted to put that forth and see if we can get through the combo.
I don't know if I necessarily call it like an atmospheric tent, but if you look at the image that you're referring to there in the chat, if you take any of those lines to be angles, right, from the flat base of that, you're always going to make that point in the very center is always going to be the vertex to any object that you're measuring to in relation to the ground in which you're standing on, or whatever horizontal you want to make. Cuts through the center of your eye, technically, is where it would be.
So again, this would presuppose two different things. One, it would presuppose that this dome actually exists, and two, it would also presuppose that the angular size of the sun would change throughout the day, which it doesn't. I was able to.
Nobody said it's an actual fucking dome. Jesus Christ, man.
Whether you call it a dome, a tent, magical unicorn farts, I don't give a fuck, dude. The concept is the same. It would be making a prediction. The angular size of the sun would change throughout the day. That does not happen.
What leads you to believe that the angular size of the sun would change throughout the day, based on your perspective?
Model. If you wanted to go ahead and if you have a nice, tangy, refreshing drink in your hand and you hold it up at arm's length, it will show up as one angular size. Now move it right over your head and pass it over to your other arm. You will see that in the process of doing that, the can got bigger in your vision, and then it got smaller in your vision again. That same motion would also apply to the sun, because the sun also has an angular size that can be measured. And I did that. I did that on my video that I posted, was it 5 fucking years ago at this point?
Yeah, but the higher something is and the further away it is, the less that you would experience that. And there is a size change to the sun. It's not always the same.
Not to the extent that is predicted. The extent that it is predicted is a factor of 2.
Predicted based on what?
Based on the actual model. If I were
what actual model?
There you go. The preset.
What actual model are you referring to that somehow gives this prediction that it would change?
Good question. Let's go ahead and take a look together. Are you seeing my screen?
Hey, by the way, that image I posted, the atmospheric tent thing, I was trying to pull up with through AI to try to see where that was from. And it says it was published as part of a Lady Blunt. So Lady Elizabeth Ann Blunt, however that's pronounced. If you guys know, she was a flat Earth. She wrote about flat Earth and wrote books. And Zetetic Astronomy is one of her books, which is the same name as Robothams, but it's a different book. Anyway, it's her book. She also talks about the 2 24-hour suns in the north and south, and shows how it's like a figure 8, like the 2 rotations of the north and south. Lady Blunt as well. But anyways, that atmospheric tent thing is that's who it's from, and it says it's from a monthly periodical in. It's called The Earth, a monthly magazine of. Sorry, it's called The Earth, a monthly magazine of sense and science, which which she edited and published starting in 1900. So anyways, that's what that's from.
Excellent. Anyway, so here I have this camera right here. I'm tracking the sun right here. Now I'm going to make this very clear. It doesn't matter the altitude. I just did this for an example. But anyway, as you can see, the camera is going to be tracking the sun all day long, as we're about to do in reality. So let's see what happens if we look at the viewfinder. Here's the viewfinder, P1000 and P900 respectively, both at 1080p resolution. Let's play till noon. Notice how the sun grows in angular size as we get closer to solar noon. There's solar noon. Notice how afterwards, the angular size of the sun shrinks in the viewfinder. So the only way for me to actually know if this is actually the case is to go out and do it in reality. But who would be, crazy enough to go out into the sun and record with a Nikon P1000 with a solar filter and a telescope mount that can track the sun all day long without much effort? Oh shit, it's Red's Rhetoric. So that's exactly what I did. I tracked the sun all day long from sunrise to sunset, and the angular size of the sun did not change throughout the day as is predicted by the flat Earth.
What flat Earth are you talking about, dude? Like who gave you some sort of what measurement? Yeah, what measurement are you using to beat up some sort of straw man? What distance did I give you to the sun? What size did I give you to the sun?
How long was the time lapse of the video?
Wait, hold on. Can we just let Napalm go through this real quick? I
thought you asked me a question.
Yeah, he is. Let's just let Napalm and Reds go back and forth on. Go ahead.
So what model were you using? Because I didn't give you some sort of distance or model or anything like that. So what model are you trying to beat up or straw man?
Well, actually,
I didn't say.
It's okay, because you weren't listening. I will repeat myself. I said, I only placed the sun here as an example. You could use any distance. The problem will remain. So I'll tell you what, you give me a potential altitude or a potential actual size of the sun, and I will show you how it doesn't match reality. The only way, and I mean the only way, for you to make it even remotely match reality is to place the sun really, really, really far away when it comes to the angular size, but then you'll have the sunset problem to deal with, which wouldn't happen if you went too far out. So please, give me an altitude, give me
Can you show me the footage of your sun at sunset from that day?
Sure. 1 second.
I mean, by the way, this did kind of shift to the angular size. We were talking about the atmospheric, hemispherical view.
He doesn't understand that concept. So
I have a question about the trick.
It falls short on him. He lacks the ability to think that he might be incorrect in something, or that there's a concept that he just doesn't know about. So,
well, you know what? Feelings mutual, my man. I recommend you.
No, I learned all about. I learned all about.
Yeah, except the actual law perspective, which I think is very important in this case.
Oh, what is the law of perspective? Can you give that to me?
Yeah, alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object, g is the actual size of the object, and r is the distance to the object. The law of perspective states that as an object gets further away from you, the available resolution of your eye will eventually become insufficient to make out the object. The law of perspective does not state in any way, shape, or form that as an object gets further away from you, it will eventually disappear bottom up and eventually out of sight, because that is literally not what it means to disappear in totality. It also says that as an object gets further away from you, the angular size will decrease proportional to its distance, which can be found via the equation I literally just gave. Did you understand that? Or would you like me to repeat it?
How is that relative to? So you're talking about like a vanishing point, right? Or things that are becoming smaller with distance. So what does that have to do with the perspective that we were talking about?
Because if you were talking about using that model that Geo just sent, that Geo was talking about the tent, that model has a consequence given the law of perspective. That consequence being that, hey, if this model were the case, the angular size of the sun should change throughout the day. If it doesn't, then that's a problem with what was previously shown. That's what it has to do with it. I'm sorry you weren't paying attention, but that's where we are. Do try to keep up.
No, angular size has nothing to do with how you would visually see something.
Even though I literally
explained how we're talking about. Yeah, so if you're going to talk over me, you can't learn things by talking, right? So you're trying to skew this conversation to a conversation about angular size. Can you explain to me where angular size was a part of the what we put forth?
So do you want me to repeat literally everything I just said? Okay, I'll say it slower for you. Geo brought up a particular model. This model has particular consequences. One of the consequences is the angular size of the sun. What about the angular size of the sun? It is about whether or not the angular size of the sun changes throughout the day. What dictates that? The law of perspective. What is the law of perspective? Alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object, g is the actual size of the object, and r is the distance to the object. So it all started when Geo showed something. I demonstrate that thing he showed does not match reality given actual observations that were actually done not by NASA. And now you're asking me, what does this have to do with what we just said? Even though I literally just explained twice how it has to do with what was just said.
Yeah, well, as things move into denser parts of the atmosphere, they can appear larger. So there's a perfect explanation for that with your sun.
What I saw at all.
Oh, really?
Actually.
Oh, really?
Oh, really? Yeah.
Oh, really?
Yeah.
So
really.
if we expect an object to get smaller as it's getting further away, but it's getting into a more dense part of the atmosphere, that's what you said. The law of perspective, allegedly. Oh, so when an object gets further away from you, you don't expect it to appear smaller.
No, you said that was due to the atmosphere.
No.
I didn't say it was due to the atmosphere.
You have a listening problem, right?
And
so
you
you take the atmosphere out of
what
this.
you were saying.
Yeah. You have an inability to understand what I'm saying. So when we have a celestial
a lot of
object,
people will probably have an inability of
that's
understanding.
cool. So just talk over me because it's obvious that you don't want to listen. So
By
I'm just going to
keep
disengage. I'm just going to disengage because you're acting in bad faith. Like I think everybody else has previously, because you can't control yourself. You just spurge all over the microphone because you can't understand simple concepts.
Hold on.
Maybe let's intellectuals down. Who's next?
All right, can we just reset somehow? Can we just let Napalm finish if you want to continue, Napalm? Can we just try to...
I mean, if I'm going to continue, I'm just going to mute the guy so that I can fully get out what I'm trying to say without him trying to speak over me and then move the goalpost like he did previously, right? We're no longer talking about the concepts we were previously.
Literally explained how this train of thought worked.
All right, let's just reset. Reds, if you could just stay muted while he speaks until you can respond, if that's okay.
Actually, given the fact it's now 1:30 in the morning, I'm probably going to
go ahead and run.
Go run, bitch.
Go run.
Hold on, you guys. The thing about
Red's like 4 hours, but he's running.
Yeah, I'm here for 4 hours. I'm just going to say that Red's running. That way I can feel better about the ass kicking I received. Fuck you.
Not my fault. You don't understand.
Reds, I enjoyed it tonight, brother.
I appreciate it.
Before you go, you claim to be making no presuppositions, but throughout this conversation, I took a step back and I wrote down. I found 13 presuppositions that you were making with your little experiment. You want to hear them?
And I actually wrote down something, and I found 13 presuppositions that you probably falsely define as presuppositions. I guess we're both going to be disappointed with this conversation.
You are total moron.
So
yeah, the timing on that does look like wrong.
The very first presup you make is that you treat reality, or that reality can be turned into a geometric diagram.
That was yours, not mine.
No, that's you. You are.
No, that was you. But it's okay. Argue against yourself.
No, that was you, actually.
No, that was him, because he said that it would be valid to make mathematical representations of reality. He agreed with that, and now he's arguing against himself. It's fine. I'm used to this level of self-contradictory statements from flat earthers, so please continue.
No, you were force-feeding that to him and trying to get him to agree with it, and then making a grander statement about his agreement, which was only partial, and you didn't realize.
It's okay. Everything's been recorded.
Yeah, it's okay.
I'll
it is recorded.
Let's take it later and show you that you're wrong. That's fine.
Cool story, bro. Go ahead and run.
Yeah, you're just trying to force feed everything and act like you were.
Yeah.
So anyway, Cole, I love you. Thank you so much, man. I really do appreciate you.
Cut through the earth and actually measure the angle from the center of the earth.
Yeah, you want to flee.
He gets 7 miles down, but he went to the center.
Yeah, I know. Angles are hard, guys.
You didn't even know what a vertex was. You didn't even know what a vertex was.
Yeah, he couldn't even define vertex when asked.
I literally defined it to you.
He totally defined it correctly. I looked it up as soon as he said it. I looked it up and he was totally correct. And you were acting like he didn't know the definition, but he was totally correct. I looked it up as he was saying it, and he was totally on target. He was totally on target. You acted like he didn't know, but he totally did know. And then you had to go, oh, I agree with you.
Hey, what's the definition of vertex? I don't know. That was classic, man. And by the way, just so you're aware, Napalm.
That was classic because you were acting like you knew it. You actually made it correct. Yeah. He made a correct definition of it. He didn't know the exact definition off the head. That's one thing. But he actually was correct.
Dave, let's take a bet that he takes that clip and he cuts off where I said, I don't know. It's the point in which the two angles meet. It's right there in the corner.
Yeah.
And he's going to cut that off and he's going to say,
a manner of speaking.
I don't know. And he's just going to cut that right there because he's a disingenuous guy who just wants views on YouTube because he's a little pansy-ass little, exactly. I'm in Florida too.
Nice job, by the way, Napalm. Nice job tonight. I mean, there's definitely
he doesn't understand simple concepts. It's easy. It's easy.
I love the patting circle, Derek. It's amazing.
Yeah, like...
Keep going.
With you and Cole?
Here's where he feigns victory.
No. Keep going. I'm almost there. Keep going.
Hold on, you guys. The thing about Reds, he's willing to defend himself.
Cole's getting you there, isn't he?
And now he's going to make some sexual remark to make it funny because he can just leave on that.
There we go. Keep going. Let the rage flow through you. Feel the dark side.
Remember, we could win people over with the ideas rather than the insults.
Eden, quick question. Did you ever wanted to have a repeat of that conversation about the Bible?
Yeah. Definitely. Join us again soon, or if you have a server, you can invite me.
So if I invite you to my server, would you be willing to come on to talk about Bible stuff?
For sure.
Okay, then that's actually how I'll end this. I'll send you a link to my Discord server. Let's talk Bible stuff, and I'll talk to you all later.
Okay.
Thank you.
How long have you guys
Thank
been
God,
working
really.
together? Exactly.
I know it's
I
hard
bet
to
you
talk to people
that
sometimes.
dude has to be single, bro. He has to be single.
Okay.
Oh no, he's talked about his old man that he has sex with and caused the old man to have a prolapse because of the rough sex. That's what he said.
Oh, jeez. I don't even want to know about that, but whatever. I'm sure he's still single either way.
Okay, well, at least we can appreciate. Sometimes there's people on the other side that are going to be quite sharp, even though we disagree. Maybe think it's crazy. At least it'll help us be just as sharp, if not sharper. So this is the challenge, right?
He was
if we can
dull. The
convert
problem
Red's
is he was
rhetoric.
dull. He was dull. There was
He's
nothing
not so
sharp about
sharp.
his. Yeah.
Yeah, he's just making
just
a claim,
rhetoric.
and then he's denying
As his name
any
says.
kind of introspection into it, and then forcefully continues to like he's making a tribunal to which you have to answer to. If you don't, then he tells you you're retarded, and he comes with like sexual innuendo, and he plays on views and humor, or like trying to make you into an entertaining piece. That's just it.
Yeah,
Like he
but we're
doesn't
all
do anything
adults
else.
here. We're all.
Is he going to
I
clip
get what you're
that?
Yeah,
saying.
he's
I actually
always been
didn't like him at
tactical. He's
first.
like the king of tactics. Like he's always been that way, just impossible, always like straw manning and repeating what you said in a different way. Just it's like it's all about winning the conversation rather than being right with him.
I don't know. I've had personal conversations with him. It's not been like that.
Yeah, but when you have a personal conversation, like if you go on one in a like with anyone,
Yeah,
that is the
but
case.
let's
I
hear you
guess, yeah,
say that
long
after
enough.
you go and talk to him about religion on his channel. I'm sure he'll be totally fair to you on that.
But okay, yeah, I get what you're saying. You guys, honestly, when I first heard of him and I was listening to him, I did not like him at all. I promise you guys. But the more that I've chatted with him, he's grown on me, and like at least he's contributing to like, even though he might be wrong about certain things, right? But what he's capturing, like the rocket landing down, like I didn't believe that. I thought that was all CGI, but it seems like he was able to capture the United States at least. Having some sort of rocket land, like maybe not all of the videos are real, but I think he did capture one that could be real, and so at least he's contributing, right? So
Yeah, you know what? The benefit of the doubt can go too far sometimes, Eden.
for sure. But my goal is to convert him because I want to hear the response of all the other Globers when we get Red's rhetoric.
Oh, you're never going to convert the guy. If he ever thought you were right, you just wouldn't hear from him again. He would never admit it.
Maybe. I think I've asked him would he change his mind, and I think he said yes.
He would not change his mind. You know, dude, when the Bible
I
says
know.
when you throw seeds, hold on, when you throw the seeds, some land in good soil and some land in the rock, that's the rock.
Appreciate your optimism, though, Eden. It can go to an extent where it becomes like, more an annoyance or something that doesn't really, grant that perspective. But we appreciate your optimism for sure.
Thank you, and thank you guys as well for your patience with me. You guys are great. It's actually great hearing you guys chat with him. So keep up the great work.
Yeah, nice job again, Napalm. It's good to hear you back in here on a level that most ballers or any baller, most flat earthers can't live up to.
No, well, I don't know about that, but I appreciate the kind words, Dave.
Yeah, I didn't mean to frame it that way, that you're better than everybody else, but you're better than most, that's for sure.
Well, it would be nice if I'd be able to get my full concepts out, but I think that's his whole point, is to ensure that doesn't happen. So
yeah, and he would never agree with it even if he listened. So it's a pointless conversation with him, in my opinion.
Well, when it gets a bit hectic, that's why like a more structured type of back and forth to where the people are actually muted if needed. But yeah, when there's all the side comments and stuff, it does make it difficult sometimes to lay a point out.
yeah, it's a side comment to come in to then throw out a straw man about something that's different. So now you're off of what you were talking about to a straw man that was from a concept that was previous. And yeah.
And yeah, that behavior is going to make the worst of us come out. Like you were throwing some insults back at him, and it doesn't, that just starts to derail everything. It wasn't you, but like if he's just not listening and insulting you, there's only one way to even come back from that is to say something similar. But yeah, he was strawmanning you the whole time, and then repeating what you said, but then leaving out certain things or adding certain things.
Yeah, and I had to come back at it, especially with the term. I was just throwing vertex out there because that's what my assumption was. The corner of that angle is a vertex, and I was like, I
yeah,
don't
you
know,
were totally right. I looked it
the
up.
angle.
Fine,
Like,
too.
yeah.
And then he's like, okay, well, then you were like, okay, so then you challenged him back, and he's like, okay, I agree with what you're saying. Like he knew it was right, or he didn't know at all, but he was just trying to intimidate you. It's just tactics. He's just, he's very annoying.
And he still didn't understand the original concept that Gio and I were putting out there. His assumption would be that you would traverse inside of a fixed dome. Like he still, I think, was leaving the conversation and logged off, still thinking that that's the case.
Yeah, it's always funny when they claim that they know it wouldn't work on a flat Earth. Like they've tried every possible way for it to work. Like they're desperate for it to work on a flat Earth, and they exhausted all the options, and it's just not possible. We tried our hardest. Like they have any idea what would work and not work on a flat Earth, other than to assume it wouldn't work.
Well, give us an option we can actually test, something where we could do a concrete test to verify it.
Yeah, measure the Earth beneath your feet to be curving at the claimed rate that it would be if the Earth was a sphere. Physical measurement.
Now give us the flat model that we can apply this methodology to see whether it works or not. So apply methodology.
The flat model is that the Earth is flat, but it does have elevation changes, right? It's a topographical plane. And if you want to measure things in the sky, you're measuring to a perspective that seems to have a limitation of a spherical type hemisphere with a radius of 3,959-ish kind of miles to it.
Okay, so give us a model of that we can then apply
that is the model.
Physics and geometry to.
That is the model. Apply the physics and geometry to that.
There's no way we can physically... well, I've not seen any way we can represent that in a way that we could test it, physically measure something.
Cool. So give me the way when Reds was saying that he measured the angle to the center of the Earth. How can we confirm that his angle is correct?
So I missed the bit when he described that, but I think he was doing a kind of an arc length measurement, wasn't he? I'm not sure.
Yeah. So how do we confirm? Like, how do we lay measure to the center of the Earth to confirm that what he's claiming is correct?
Well, we can confirm it with other similar.
So we can't, right?
Methods. Something like GPS also gives us a curvature measurement and the radius and the location of the center, right?
No, it takes coordinates and wraps them around a WGS84.
No, it doesn't. It doesn't.
Yeah, it does. It converts them.
It does presuppose. Like you're conflating direct measurement with measurement within a model bounded frame. Like it's
okay.
It's just ad infinitum with that.
What is the method?
Categorize correctly, dude.
So you take an elevation angle, then you move 3 miles down the road and take another elevation angle?
Yeah, this is what I was gonna talk about or tell this guy before he left, but he didn't. But it pretty much goes. What he was doing is that first he presupposes that the reality can be turned into a geometrical diagram, and then now we have a diagram, right? The next thing then with the Mars thing is that Mars may be treated as a fixed point in that diagram. Then that both observers are operating inside the same shared spatial frame. Then that the distance between the two observers is already known. And then that the Earth's shape, size, and surface relations are already correctly modeled. So here's the model already coming in. And then that the angles they measure correspond to actual sight lines. And that light or vision travels reliably enough to define those sight lines. And then that the atmosphere, refraction, or instrument error and timing error are either absent or correctable. And that both observers are looking at the same object, i.e. Mars at this, and that the observations are simultaneous or time-corrected properly, and that trigonometry applies not only inside mathematics, but to the actual physical scene, which was my main point, and that indirect calculation can be called measurement, which is the point we're talking about now. Indirect calculation in the model frame, called measurement in reality. And then lastly, that the resulting number is the distance itself rather than the model bound determination, which was my whole point consistently throughout for the last, lifetime that I spent here right now. So
that's an impressive list of assumptions that he made there. Nice job.
Yeah. So that will also reject any flat Earth model that you could come up with as well, right? That will immediately eliminate.
Oh yeah, any flat Earth model has already been tested, and we rule that out. Sure, you exhausted yourself.
You see, this is why Daza, when you say that I'm a flat earther, if you actually listen to what I said, this should be enough to tell you that I'm not. So to condense that one into a simple line then, so it comes off as coherent, because that was a lot, right? The mistake here is to presuppose a shared Earth frame, a known baseline, a reliable sight lines, correct instruments, synchronized observation, Euclidean or trigonometric applicability, and then call that the calculated model result, in quotes, the measured distance.
So even if he had all those things correct, the mere fact that it's a calculation with, the assumed radius, even though he says that was also measured. It's already ruled out as anything that you can call a measurement. You can't just start changing the words and calling it one thing when it's actually another. Just admit that it's a calculation and say, well, this is a calculation. I have to admit that. But no, a measurement is the same thing as a calculation, which is just a category error.
He doesn't track the category errors, and it just spirals into him attacking and slandering, and every time you point it out, he tries to shift it into you being like stupid, or you're like this or that, or he tries to play on this like asinine gay humor with talking about butt fucking old men and stuff. Like, it's just really stupid. Like what the fuck?
All right.
I'm sorry to say it out loud, Gio, but it's just
that would be better if that was not on the live stream. But can we just carry on here? So, that's just not needed. Anyways, it is basically a different of an elevation angle at the end of the day. Like, it's someone in Florida and someone in Colorado taking a view to Mars. So at the end of the day, it's like if you had two planetarium setups, even if they were right next to each other, you had two planetariums next to each other. One of them is set for Florida, one of them is set for Colorado, and you walk inside the one, then you go inside the other, then you go back and forth. It's essentially what it is. It's just a different angle and different position, and then a whole bunch of assumptions based around why the change is there, why the difference in the angle, and then making extrapolations into the globe model with the assumptions of the radius as well.
Except it's one planetarium, right? Everybody's looking at the same planetarium, Geo, from different positions. If you want to have an individual planetarium model, which is effectively what Napalm was describing, then we need to be able to justify why that would exist physically. Why there would be something 1 Earth radius away that causes the view for you to be different to everybody else's view.
1 Earth radius? Where'd you get the radius?
Well, Napalm either way, about the dome of vision thing being 3,600 miles or whatever.
Either way, everybody's view is always going to be different than yours. That's the whole entire point.
Yeah, you got to work out why. That's the big question, right?
I already laid.
You should work that out too. You should be concerned about the same thing. You're just assuming it's one way and then ruling out every other option.
Well, I've not seen any evidence to say it's any other way.
Oh yeah, the fact that we experience a stationary and level Earth just like every other human ever in existence, 24/7 for their whole lives.
No, you say that we experience it, but that's not how we measure it, right? It's particularly at global scale.
Do you at least admit calculations are not measurements?
Oh, yeah, we have to do some calculations, right? Because it's too big to measure directly.
Okay, so you can't measure it directly. You're not talking about direct measurements. When you say measurements, you mean calculations, right?
Yeah, measurements based on the speed of light and things like that we know pretty well.
Yeah, that's also an assumption.
Well, you can assume everything. How many assumptions do you have to make for your flat Earth model to work?
None. The Earth is stationary and level just like it seems in every possible.
Okay, so I'll give you one simple case. The well-known 1 degree per 60 nautical miles change in elevation. What assumptions do you have to make that work on a flat Earth?
The Habersign? Is that what you're talking about?
No. Physical angle change. So with every nautical mile that you travel...
Yeah, it's just perspective.
So show me that. What assumptions have you had to make the geometry and the trigonometry work?
Well, if we're on a stationary Earth, which is very obvious to a lot of people now, except for the people assuming it's not stationary. And since we're on a stationary Earth, things are getting lower in the sky. That's not much of an assumption. They're getting lower in the sky.
So you take the arc minutes and you divide that by 360.
Yeah, the baseline standard should be that the ground is not moving. That's not me saying that I'm whatever you want to claim it's having said.
That's a default position. That's just the base axiom default position. Since we're not
even I can admit to that.
Yeah, exactly. It's a stationary Earth. Let's go from there.
I'm not noticing being in movement. Doesn't mean that it isn't necessarily, but it's not noticed. So we create a standard. It's called a normal, a standard, and then we operate from there. And
if you're sitting in a chair, you don't have to believe you're sitting in a chair. It's just your base assumption that you're sitting in a chair. But now you might not be sitting in a chair, but that's not really relevant to a conversation where we're talking about a stationary Earth that we all experience.
Yeah, just like we create a baseline for men and women to procreate, right? There's the baseline. Then things can deviate, but the baseline is still the same. It remains men-women relationship for procreation. So creating a baseline isn't bad. But you move the baseline into the model. But you have to presuppose the model, ignoring the standard that's already there in existence, that it's not moving. And then you try to place that after into as an explanation. Sure, it could like again be the case that the ground is not noticeably moving, but is. But still, you cannot discount the fact that you don't notice it. Doesn't mean that it does or doesn't.
And we know a lot about motion, right? That if two things are moving at constant velocity to each other, and you've got no other frame of reference, you cannot tell that you're moving relative to that other thing. So the Earth could be moving, and we just don't know because of that same logical inference, right?
Yeah, we can just take piece there right there.
But if we make some observations of other moving objects, for example, we might get some hints that the Earth is moving, particularly accelerating, moving, or rotating, right? That we know that if we have a rotating frame, that we can detect changes in projectile motion, for example.
So this is like equal to a case I just read on Instagram about there's this university in Oslo. It's just called that actually, where there is this woman who has a master thesis where she is reinterpreting old cave paintings, and one of those cave paintings is I think it was cave paintings. At least there's some paintings, right? One of them is some kind of like stickman figure standing up against something that looks like another kind of stick thingy, but not necessarily a man. And then she goes on to claim that it's a homosexual interrelation there. But you're looking at it, and it's just like some stick man and some lines. So it's an added interpretation onto something that's not necessarily the case. But then she goes the next step to say that it is a depiction of that, not her interpretation. So the problem with the model is that most go into that same category error or jumping to the conclusion. Like it's like the model bakes in them just committing every kind of fallacy.
Well, if it is a stationary Earth, which seems obvious, like I said, to a lot of people now, then what? There's really not much of an option other than to do that for the argument on the other side. There's really no way out other than just to make assumptions or commit fallacies. I mean, it's obvious every time any of these conversations go on.
So you guys know that for me, the go-to modern evidence of the shape of the Earth is GPS, right? And I'm still to hear a solid rebuttal that would make me think that, first of all, that it's anything other than what it's claimed to be, and secondly, that it shows anything other than the Earth as being a sphere that is rotating relative to an inertial reference.
I think I already addressed.
I've heard many conversations where you get wrecked on that. I mean, you can't just assume that whatever the GPS says. I mean, you admit yourself that if it is a reverse engineered model and they have spoofing, or even if they have, satellites, which I think there are satellites, and it's using the electromagnetic field, and a lot of the GPS is correct for good reason, but it doesn't have anything to do with curvature or being on a ball. I mean,
doesn't it start off with Earth fixed Earth centric, and then it switches over to latitude, longitude? In other words, it starts with a Cartesian coordinate.
Yeah, so you're right. There are two components. So the raw GPS location information ends up as a Cartesian XYZ coordinate, with the center of the Earth as the origin and the North Pole, South Pole as one of the the rotating axis. But then to convert that to lat long, so everyone's comfortable, because lat long is what we use, you have to then project that position onto the globe. And the globe can be measured independently, right? Because that XYZ position has no bearing on the globe other than the origin, and other than the center of mass of the Earth being the origin, and you can determine that independently of the surface. You could potentially, from satellites, reverse engineer the shape of the Earth just by observing them, working out what their path is, and the path will be around the center of the Earth, and from that you can then determine the shape of the Earth relative to those satellite paths, which is how GPS does it effectively.
Yeah, when you get the velocity or the acceleration, the movement, the speed of a plane, right, is measured against an absolute reference frame of a stationary Earth. If it was a moving Earth, not to even get into this conversation, but that's just plain simple. The plane's going a certain speed in comparison to a stationary Earth. If it was a moving Earth, there would be no way to measure the speed of a plane.
The plane is measuring its speed two ways. So if it's able to measure speed relative to the ground, with radar it can, but if it's otherwise it's measuring airspeed, right? And
but if it was a moving ground, it would be a totally different measurement as it goes over the tangential velocity gradient. Yeah, because it would be in relation to 0 miles per hour eastward tangential velocity all the way up to 1,000 miles an hour eastward tangential velocity. That would throw all of the speeds into a different measurement completely. It has to be measured against the stationary Earth.
I'll ask you then, how does an aircraft actually determine its speed? What is it measuring?
Measuring its forward velocity in comparison to a stationary ground.
Just to the ground. Whether the ground's stationary or not is irrelevant when it comes to measuring its
It's not
velocity.
irrelevant because the ground has a velocity that change or an acceleration change from 0 to 1,000 miles an hour. So depending on where the plane is over the Earth, that speed would be calculated completely differently. It's always in relation to a stationary Earth.
So physically, how does the aircraft calculate its speed? How does the pilot know what his speed is? What is the mechanism for that?
I'm telling you, it's in relation to a stationary Earth.
Now, what is the mechanism? I don't care what it's relative to. What is the physical mechanism that allows the aircraft to determine its speed?
Accelerometer? I don't know.
Yeah, you don't know. So two ways, right?
Well, what is it? Say what it is.
If it has radar and is able to reach the ground, it can measure its speed by radar, Doppler radar.
And if it was a moving ground, it'd be a totally different reading, yes or no?
No. The Doppler will only show the speed of the aircraft relative to the ground. So it doesn't matter how fast
it's a stationary ground
are moving.
It does matter.
So all aircraft speed measurement is relative to the ground, regardless of what the ground is
but if it's the speed between two different points on the ground, with the ground's moving, it'd be a totally different measurement.
No. It's like if you
because
if
the Earth would be either moving towards you or away from you.
Yeah, it would be moving at different speeds depending on where you are on the Earth.
No.
It could be moving 1,000 miles an hour eastward at one point, or 10 miles an hour eastward, and that would change the whole measurement of your speed between two different fixed points on Earth. The fixed points on Earth have to be fixed below the stationary. It has to be stationary below the moving vehicle above. It has to be fixed. They don't ever account for the tangential velocity gradient. It's a whole other point. That's the whole argument we've been through, just exhausted with that. And you just act like it doesn't matter if it's stationary or moving, and the tangential velocity wouldn't matter. When the plane's trying to land, and it would have to be going the exact speed in that eastward vector without its forward motion changing whatsoever based on that. How could it be moving at 1,000 miles an hour in perfect sync with the Earth as it's trying to land at some weird angle facing against the spin? You just assume it's moving with the Earth. There's no function to that whatsoever. There's no dynamics that would even make any sense. The atmosphere moving with it doesn't even have the forces involved, and the calculations wouldn't even work anyway because it would be so many variables with the winds moving in the opposite direction. Yeah, it's just a dead-end conversation, Daza. Let's not have it right now.
Okay, we don't need to go down the airplane path, but the whole relative velocity thing is critical, right? So if you were to ride a bicycle up an aircraft, up the aisle of an airplane with a speedometer, the only speed you will register is your speed relative to the aircraft. Okay, that's the same.
That's a non sequitur. That's non sequitur because it's one linear path up and down, a moving object inside a sealed container, and that's not even comparable because the Earth isn't contained in the same way, and it'd be a tangential velocity gradient of 0 to 1,000 miles an hour. That's not evident within the plane that you would have a different velocity depending on where you are in the plane. It's total non sequitur. It's just like they say, you don't feel moving on a plane, so you could be going all these different directions at different speeds, and it'd be the same thing. It's just going on one linear direction with the airplane. Not the same. I don't know how this is good enough for you after all these years.
Yeah, it's pretty crazy.
It's relatively straightforward physics, the relative velocity, even if you ignore everything, right?
It's not straightforward. What about the tangential velocity gradient? That's not present, and it's a non sequitur for that reason alone.
So if we just ignore whether or not the globe is true for a minute, right, and assume that an aircraft is flying along a ground track from north to south across the equator and following a pre-planned route, ignoring any forces or whatever, the aircraft will never exceed ground speed by what its airspeed is allowed to be, right? So it's never getting out of sync with the Earth. Which means it would
be out of sync as soon as it goes in the air. When it goes in the air, you're using the conserved momentum to justify that the ground isn't moving separately below. That's what your side has to do. We're assuming that because it was on the ground, it's moving at the same speed of the ground. And even if it's in the air, it's still moving because it was on the ground. Then when it goes over the tangential velocity gradient, gets to the higher miles per hour, then you start using the atmosphere somehow making it perfectly in sync. So the pilot doesn't have to worry about it. The magical atmosphere then starts coming in to help you out. It's no longer the conserved momentum. Oh wait, maybe it's a little bit of the conserved momentum and a little bit of the atmosphere. And the plane also, the pilot's veering, he's banking to try to keep up with the ground path and all those different, like a combination of things that you try to use to make that justified, that he would never have to worry about it and land the plane as if it's perfectly stationary. The only way for that to be happening at all in any kind of sensible way is that it actually is stationary. You can't just get out of it by adding these things that justify it in your mind. It's almost like I can't believe you believe it.
So if had a radio controlled plane inside another aircraft, would I have to change my strategy for landing that remote controlled plane depending on whether the
Is there a tangential velocity gradient
whether
within
the
that
aircraft
aircraft?
was in flight or not? Let me finish, please. So
Where's the tangential velocity gradient?
Would I have to alter my strategy depending on whether the aircraft that I was flying around inside was in flight or not?
I just told you why it's a non sequitur, and you just ignored it and used the same example as if I never said anything.
No, it's
And I hear a lot of
identical.
assumptions and presumptions and hypotheticals and ifs and woulds and coulds.
Oh yeah, because we're trying to establish.
It'd be more like trying to fly. It's like more like trying to land the aircraft on another plane that's going the opposite direction, or even at a different speed in the same direction. And then you would be like, "Oh yeah, it's just the matter of being in sync, and it all works out perfectly." When you're trying to fly the aircraft from the top of one plane onto another plane going 1,000 miles an hour at a different velocity, or different acceleration. That's the better example rather than inside the container of an airplane or airplane or all these things that have always just been good enough for you, right? Like that's really. It's a non sequitur to begin with, but I can't believe it keeps you believing it.
I think a better scenario, if you want to go from aircraft to aircraft, would be to have two aircraft catch up to each other, match the speed, and then transfer from aircraft to aircraft through a tunnel, right? That's more.
But the point is, it's not the same speed. The equator is moving at a different speed than the rest of the places on Earth.
Okay, so how long have we got to get from the North Pole to the equator? 8 or 10 hours?
Sure, yeah. If you want to walk through it, we can walk through it, and I'll walk you right into the ground again because it won't work. Go ahead. Doesn't matter about the distance. I mean, he could have no ground path, right? My scenario, if you really want to walk through that argument with me, Daza, it's a joyriding pilot. He's flying all over the place. He's going up and down different tangential velocities and many different places. He's got no destination, but he's generally flying west-southwest against the spin, and he's going to land in a clearing somewhere, wherever he feels like, at whatever point, where it's actually moving at 500 miles per hour faster than where he took off from. How is he always going to be able to treat it as in sync at that point? Just always able to treat it as stationary no matter what. No ground path, right? No banking to try to catch up or to stay in sync. None of that, right? And then the atmosphere would have to be pushing him one way and the other way, just the right amount so that he's in the exact same tangential velocity at whatever latitude he happens to be in. Can you really walk through it and make it make sense with that scenario?
Okay, I'll have a crack. So in that scenario, on average, what is the wind speed over the ground?
Undeterminable, right?
No,
you can make an average. You can make an average, but an average isn't good enough because you can't just say, oh, the atmosphere is generally some kind of estimation where generally or more so than not in sync with the Earth. That doesn't work to make any kind of estimations. When he lands the plane, he treats it as perfectly stationary. Not an estimation, not generally, not more or less. All those estimation words are just ways of justifying the idea that it could possibly work.
So can we make some assumptions to help us understand what's going on?
You can't make any assumptions about the wind. The wind's totally unpredictable in different directions.
Can we say that it's never more than 100 miles an hour if we're flying close to the
But we're talking about a pilot that's going to have to land. He's going to have to be sure, no matter what, that he's going to be able to treat the Earth as stationary because he's got passengers that the lives are on the line. If he lands that plane, there can't be any estimations. So we generally think the wind's going in this direction, so we're generally going to make sure that we're doing. No, none of that's even thought about.
Okay. Can we say that the wind? We're flying close to the ground. We've got no cyclones. Can we say that the wind will never be more than 100 miles an hour relative to the ground? We'll have no more wind speed than 100 miles an hour. Is that a fair thing to say to have this conversation?
Wait. When you say wind, are you talking about the atmosphere pushing the plane?
I'm talking about the air speed relative to the ground.
Right.
Will the wind?
Right, but the air pushing the plane, right? Like if you're talking about a wind, it's about a force on the plane, right?
Will you stop and listen?
The wind acts as a force on the plane, right? Is that what you're talking about?
Not yet. I'm asking you about the wind over the ground. Will the wind ever exceed ground speed by more than, say, 100 miles an hour?
If you want to make that assumption, it's not going to help you, but go ahead, just further walk through. We can do that.
Cool. So now we can say that at no point on the Earth is the air moving over the surface of the Earth faster than 100 miles an hour. Are you happy with that?
That you can use that assumption if you need to. Go ahead.
Okay, right. Now we have an aeroplane flying through the air. How fast can it go compared to the air?
What do you mean the air? The winds?
The air. So the aircraft is flying through the air. How fast can it go compared to the wind?
Well, let's just say it's a Cessna and he maxes out at 300 miles an hour.
Yeah, so he can never go faster than the air around him by 300 miles an hour. Right.
Well, yeah, but what are you assuming a direction to the air? Well, I don't get why you're saying the air.
Oh, yeah, so it doesn't matter. So he can never have the air flowing over the aircraft more than 300 miles an hour, right?
If it's a Cessna and that's the max, it can go forward, yeah.
Yeah, cool. Okay, so we've got a maximum speed through the air of 300 miles an hour. Now, if we take that and add it to the maximum speed that the air can be traveling over the ground, which is 100, we can never be traveling more than 400 miles an hour over the ground. So regardless of where we go, we can never exceed our ground speed by 400. We can never be more than 400 miles an hour.
But then if he's going from the pole all the way to the equator, then there's a vector, an eastward tangential velocity vector change of 1,000 miles an hour.
Yeah, over like a 8 or 10 hour flight, right? So
no, he's flying all over the place. He could be in the air 24, 48 hours. He's just joyriding pilot. He's got no path. He's got no ground path, right? But you're talking about what is it that's making him in sync? That's the only question. What is causing the plane without the pilot's direction or accounting for any kind of earth spin, right? He's just flying all over the place, and he's always just treating it as stationary. He's never seeing the ground move left or right underneath him as he goes north or south, right? There's no difference, right? So the only way that could be possible is if the Earth is actually stationary. Because if you say that the plane goes up in the air, and you're assuming that it's moving with the Earth at a 500 mile per hour latitude, is it because it was on the Earth, not because the air is pushing it to be in sync, right? So you're contradicting yourself by saying, oh, it's conserved momentum, then it's the atmosphere, and it doesn't work anyway. So I just walk you to the very end. When the plane is facing against the spin at some weird angle, west-southwest, right? And even if you thought that somehow the air is pushing it in one vector eastward, even though it doesn't change his maximum amount of 300 miles an hour forward, and he's circling the airport, you have to imagine that somehow the air is carrying him at 1,000 miles an hour, and it has nothing to do with his conserved momentum or any of that. It has to be actual force. The winds could be actually blowing consistently and forcefully the opposite direction of the spin. So none of the air really helps you in this situation. And then when he's closing in on landing, you have to imagine some force, I don't know how you even justify it, is pushing the plane backwards to be in perfect sync with a ground that he's treating as perfectly stationary. It's just ridiculous to think that that'd be possible. I don't know how you could believe, and you don't even have a force that you could say is what's causing that.
So did we just?
Where's your dynamics?
Did we just agree that the aircraft cannot exceed a particular airspeed?
We already said that. It can only go 300 miles an hour max forward.
And did we agree that the airspeed over the ground cannot exceed our nominal wind speed? And we never see this on Earth.
Well, what are you talking about airspeed? Do you mean winds when you say airspeed?
So the aircraft speed relative to the air can never exceed its rated airspeed, right? And the wind speed,
are you assuming the air is moving
over the ground?
Yeah, you meant the 100 mile an hour winds as the air moving, right?
Yeah. So when we stand on the ground,
that's how we measure the air moving, right? It's winds, right?
Yeah.
We don't have a measure. We don't have any. We only have assumptions and calculations that you can do some kind of kinematic, subtraction or addition, whatever it needs to be to match the same the velocity, the miles per hour and tangential velocity, right? You're just using that in a kinematic way to say it could, the Earth's going to say it's the same exact speed as the rotation of the Earth when the plane's landing, even though he's facing the opposite direction. And you have to believe somehow that eastward vector change wouldn't be a vector addition to his forward movement. You have to just imagine that the plane's going 1,000 miles an hour backwards, even though he could only fly max 300 miles an hour forward. You get why that doesn't work physically, right?
Okay, so you've had your go several times now. I'll finish mine this time. So
all right.
we can stand at any point on Earth, stick our finger up in the air and measure the wind speed, right? And today we're saying it's no more than 100 miles an hour in any direction. We also know that our aircraft cannot physically exceed a particular airspeed, so it can't fly through the air faster than any particular speed, which means that ultimately its speed is at the mercy of the wind.
So actually, the airspeed is going to make it go faster. Like if the wind's behind you, it can make those America's yacht race. They actually fly. they actually sail into the wind, like against the wind. It's like you're kind of like using this wind wrong. Like the way you're describing it, it's wrong.
Hey, Carlos, yeah, thank you. But I think he's already going to finish himself up. Let him continue because, they could use jet streams and go faster than the supposed rotation and all those kind of things. Like the air is never predictable, but he needs it to be somehow averaged in his scenario. I don't know how to help him.
Right. So we've set our ground rules here, right? The pilot's just not flying any particular course, just heading in a vague direction. We know the wind speed over the ground is not more than 100 miles an hour, and the aircraft can't go faster than the wind by more than 300, which means that the worst case ground speed is 100 miles of wind plus 300 miles of air. So we get 400 miles across the ground, or as Good Vibe said, if we're going into the wind, we're only going to do 200 miles across the ground because the wind is slowing us down. So we know we can do the maximum speed we can get relative to the ground is somewhere between 200 and 400 miles an hour, depending on which way the wind is blowing and which way we're going. Now, as we progress down towards the equator from the North Pole, and the Earth is rotating and the airspeed is still stuck to the Earth, all we can see is what we're doing compared to the air and the ground. And that over the many, many hours it takes to cover that distance, we are dragged along with the air. And our speed relative to somebody that's watching the Earth spin from the outside is increasing, but relative to the ground and relative to the air, we're just cruising along because the air is essentially dragging us with it. And
okay, wait. I want to just make sure, because I have to stop you there with the essentially. I talked about this. The estimation was that the atmosphere is moving in perfect sync with the. No one even tried to claim that lockstep atmosphere, right? Because you can't. You have fluid dynamics. You have a different. You have a difference in, even if it was actually rotating, you'd have maybe at the surface maybe some friction that's allowing the air to go somewhat, possibly in the same direction, even though we got winds in the opposite direction because of the heat. So I mean, we got all these variables already just at the surface. But then you go up at higher altitudes, you have to assume there's some kind of, a faster air up there, and there's, these other theories that they have to throw in. It doesn't even matter. Even so, you really believe that somehow, because you're thinking that the air is stuck to the ground, but then you're going to say, oh, essentially, or more or less, and all these estimation words. It's just adding and subtracting the number and assuming that somehow this is all happening, and that the plane could be moving in an eastward direction now, 1,000 miles an hour, without his forward direction being changed whatsoever.
His
vector mass. What about vector mass?
Yeah, so the vector sum of his speed relative to the Earth is the wind speed relative to the Earth plus his speed relative to the air. So that vector sum gives his speed over the ground. So wind vector plus aircraft vector equals ground vector of the aircraft.
Yeah, but you have to also admit that you believe that the plane is moving backwards at 1,000 miles an hour, literally at 1,000 miles an hour in perfect sync because of the air. That's not even said to be in perfect sync, but for your imagination, it's moving with the air that's moving at 1,000 miles an hour backwards, literally. Not just like, we're just gonna factor that in and pretend that it's the same, and it's literally 1,000 miles an hour.
Conservation of momentum. Conservation of momentum. That's what they claim, right? It's in lockstep.
No, the conservation of momentum is the excuse when they just get off the ground because they were on the ground. But then they have to change it to the air keeping the plane in sync somehow, which doesn't even have the dynamics at all. I mean, if there was wind in the opposite direction at different speeds, different days, different, all those other factors that the pilot deals with. He's not. But if the air was causing him to accelerate from 0 to 1,000 miles an hour in an eastward direction, not only would that affect the forward motion of the plane because you have vector addition. You can't just say, oh yeah, the plane's going 1,000 miles an hour sideways, but that doesn't affect his 300 miles per hour max forward. That doesn't work physically. You can't just say, oh, we're assuming now that it's going 1,000 miles an hour faster than where it took off from. That's just a kinematic concept that it could possibly even work. There's no dynamics that would ever even be dreamable of working in that scenario.
So a couple of things there was, so first of all, you insist on making it more complicated than it needs to be just to understand the basics, right? So we can say, let's if we wanted to make it easy to understand some of the concepts, we could say, let's pretend that it's a perfect.
Give it a ground path, right? Let's say it's a ground path, or he's going in a perfectly straight line, or all these things that we could use to somehow make the math work out, right? Go ahead. Sorry.
So let's, because you're introducing so many variables, it gets confusing, right? So let's just assume for a second that we've got no motion of air on the Earth. It's a perfectly still day, right? We've got a massive high pressure system sitting over the top of the continental United States, and there's almost no airflow at ground level. On a day like that, you can easily see that if the air was rotating with the Earth and the Earth was rotating relative to an inertial reference and the air was just traveling along with it, that an aircraft flying along would only have to be pushed sideways to keep up with the Earth a very small amount over that period of time. And the drag from the air is more than enough because you can't exceed the air. You cannot get 1,000 miles an hour of airspeed across the aircraft, right? Because it physically.
How is 1,000 miles per hour a very small amount? How is 1,000 miles per hour a very small amount? I don't get where you get that.
Because
you can say very gradually over a period of time, but it doesn't make it different than 1,000 miles per hour different, right? It's still 1,000 miles per hour, whether it's gradual or not. It's a change in the aircraft's tangential velocity, which would not only be something that you'd have to deal with and be aware of, and actually pay attention to and know all about, right? You couldn't just treat it as a stationary if that was going on. There'd be so many variables that would cause.
So why would you need to pay attention to it if it's happening? If you're gaining 1,000 miles an hour over 10 hours, that is almost insignificant compared to gusts in the wind and things like that, right?
Just thinking about it as relative to something else doesn't make it different than 1,000 miles an hour. It still has to physically be moving eastward at 1,000 miles an hour and then moving forward in any direction he likes, just moving at 300 miles an hour, circling the airport for, however long he's given to actually have the clearing to land. And then you have to imagine somehow that the atmosphere is not even supposed to be in sync, is somehow carrying him along in all these different directions as he's circling with the plane. It's just a concept that's a fix-all. Like, because we can think about the atmosphere as generally in sync, we can just say that it doesn't matter at all to the pilot, even though it's a change in tangential velocity of literally 1,000 miles an hour, which is over 3 times as fast as the plane's even able to go forward.
So
if you have a change in direction, if you have a change in velocity sideways, there's gonna be a vector mass addition to your forward velocity. You can't just say it's moving at 1,000 miles an hour now. Literally, physically, yes, it is moving that way, and only going forward at 300 miles an hour down to 0 as he lands on a stationary Earth, and still moving backwards somehow with the Earth spin without any kind of force dynamics. Just a kinematic add-on. We're just going to say this is happening, even though it's faster than the plane's even able to fly. What about the structural? I mean, none of it. To even ask any questions on top of that seems ridiculous.
So you mentioned this increase in velocity. So in physics, right, when something increases in velocity, we're accelerating it. And the rate of acceleration required to add 1,000 kilometers an hour over 10 hours is a couple of meters per second tops. Or what?
But that's why I took the ground path away, right? Because if you're saying it's gradual over a certain amount of time, then he's correcting for it, and he wouldn't know if he's correcting for the winds or the Coriolis. So he's just staying on a ground path. That's why I take it away. The only way that really works in your scenario is you're saying that the plane's correcting for the ground path there in that scenario, right? So because it's just a little bit of correction eastward over a period of time, then we could just pretend that he's moving with the Earth at 1,000 miles an hour. Is that what you're saying? Is that where you're going with that? Having a ground path to correct for makes it work for you in your mind?
It doesn't really make any difference. Having a ground path to follow makes it easier to describe what's going on.
It's a way to justify it, because you can say he's correcting for the ground path. Therefore, even though he's only going, let's say, even 100 miles an hour, it's a really small Cessna, right? And he can only go 100 miles an hour forward at any time, right? He's maxed out, right? His structure of a plane doesn't handle any more than that, right? But then you just assume that he's just physically going at 1,000 miles an hour faster than where it started from, eastward, without that affecting the forward vector of max 100 miles an hour. I mean, it could be going 1,000 miles an hour eastward physically, and only be traveling forward at 100 miles an hour without that eastward vector at different angles, different times over the flight, back and forth over different tangential velocities. Somehow you just think that it's going to be moving along with the surface of the Earth perfectly. There's no force there. The force of the atmosphere is the winds. That's not the air moving him eastward faster. The winds are the only thing that pushes the plane, not the atmosphere as a whole. That's just a concept.
The winds can. So would you agree that the wind can never go faster than the aircraft's maximum airspeed, as far as the aircraft is concerned, right? So it can never see air flowing over it faster than the wind speed. So imagine this situation, new perspective, that we've got our little Cessna. Let's say it's a light aircraft, like one of those ultralights. It can do 120 knots, right? And it's flying into a headwind of 200 knots. It's going backwards across the ground, right? But the pilot is only aware of the fact that he's got 100 knots of headwind. If he doesn't look at the ground, he's got no idea he's going backwards at 200 knots, right?
No, that wouldn't be possible. He couldn't. The physical movement of the aircraft is totally everything he keeps track of, right? The forward motion, the banking, the side, the crabbing, all that in response to air, which is wind, right? Not the air that's not the wind, right? Because you have to have the air that's separate from the wind somehow moving the plane.
No, the air is the wind. The air is the wind.
So if you have westward winds, then it wouldn't be moving eastward faster.
Okay. So we've got our guy on his little ultralight. It can do 100 knots. And he looks down and he's going backwards at 100 knots because he's flying into 200 knot headwind. If he didn't look down, how could he tell what his speed was?
Didn't look down? You mean at the ground?
Yeah. So if the pilot couldn't see the ground, how would he know that he would be flying backwards at 200 knots?
Because the plane changes. If you got an angle that you're going against this tangential velocity gradient,
don't worry about the tangential velocity.
You're trying to make it from point to point. You have to know exactly where you are in relation to the Earth from your readings, from your forward velocity. All those gauges on the airplane are telling him everything he needs to know. They're not telling him that there's a tangential velocity gradient of 0 to 1,000 miles an hour.
Go through the whole spiel again.
That would change everything. Hear it. Well, you don't want to hear it. I know that.
So just finish with the situation. If we've got the little guy in his ultralight, and he's looking at his instruments. He's only got a wind speed indicator and an angle of attack indicator and a compass maybe. And he's flying along and his aircraft says, I'm doing 100 knots. I'm going flat out. And he looks at the ground and he's going backwards at 100 knots. He's got no means of telling, right? Until he looks at the ground. So his speed.
He knows where he's flying to and from, right?
But only when he looks down, right? All these
Well, no, I
aircraft
mean
cares about is
you know the distance between 2 points, right? You take off at a certain speed. If you want to get to that other point, you don't have to look down to know that. You just know that the Earth is stationary, and you don't have to worry about a tangential velocity gradient, or you'd never get to where you're going. Definitely not by looking down.
But at any point in time, he's only aware of his motion through the air. Unless he explicitly tries to look at the ground, he's only aware of what his aircraft is doing relative to the air. So
yeah, but you're saying that the plane is accelerating from 0 to 1,000 miles an hour eastward,
we
as
haven't
well
even
as
got
only
there
going
yet.
100 miles an hour forward.
We haven't even got there yet. We're still talking about what he experiences at the moment, right?
If you had an acceleration change of 0 to 1,000 miles an hour, you would notice that. You would notice that completely. It would be just so many ways that would screw everything up. But go ahead with your scenario. I don't know where you're going with it.
Yeah. So at any given point in time, all the pilot can sense is how fast the air is flowing over his aircraft and what his angle of attack is. And it's only when he tries to make some external reference he knows about his ground speed. So even if he does a barrel roll or some aerobatics in that wind, he won't feel any different G-forces, whether he's going backwards.
My argument wasn't that the air. Real quick, you're assuming that my argument is that the pilot would feel the change in velocity.
I'm not. No.
Nothing to do with what he would feel. It's the physical plane can't be moving eastward 1,000 miles an hour faster physically.
So I'm trying to teach you about relative velocity. So if
I understand all that, you're not teaching me anything.
You clearly do not understand relative velocity.
I do. It's relative to a stationary ground. That's the only way it would work. If there was a difference in the ground moving underneath him eastward, that would be something he'd have to know about and pay attention to. Otherwise, even if it was moving at that speed and he was paying attention to it, it would make it impossible for him to land without being able to fly the plane backwards and forwards at the same time to land on what he would assume is a stationary Earth, what's moving underneath him, 1,000 miles an hour faster than where he took off from. It's 1 + 1 = 2 here, Daza. It has nothing to do with me not understanding.
Okay, so I'll try again. So we've got our pilot in his light aircraft. It can only do 100 knots. He's in a 200 knot airstream, and he looks down and he's going backwards. Now, if he was to do a barrel roll or a sharp banking turn and fly around in a tighter circle as he could, that circle would be moving backwards as well relative to his general direction, right? But he would not be aware that he's moving backwards relative to the ground. So his turn would feel like a turn in still air. His barrel roll would feel like a barrel roll in still air. There's no different G-forces or anything like that because he's actually moving backwards in this airstream. So he can be flying along blissfully unaware that he's actually moving backwards on average compared to the ground. This is the basics.
That's where I think that's just like the concept of he could be moving sideways eastward without any kind of effect on the plane whatsoever, not getting faster and faster as he goes towards the equator. But we're just going to say because he wouldn't be aware of it because he only knows the relative motion of his speed of the plane to the air or to the ground, which is actually stationary, even though we like to pretend that it has a tangential velocity gradient that would be faster at the equator. I mean, all that's just like the concept. You just keep it as a concept in your head. Think about it as what the pilot would be aware of or what we could measure and all these things. But the thing is, you can't have the air moving in perfect sync or moving the plane without some kind of dynamics to it. You have to have the dynamics, not just the kinematic concept that we can just pretend it's in sync, even though it's 1,000 miles an hour faster than where he took off from. It's just you pretending. So you can say he's pretending the Earth is stationary, but it's actually stationary. Because that's the only way you can pretend.
Gradient. What is the magnitude of the velocity gradient?
Dude, stop with it. They're trying to teach me magnitude. You're talking about a 0 to 1,000 miles an hour, right?
You just told me that there was no mechanism. I'm asking you what the velocity gradient actually is.
What's the mechanism of the rotation of the atmosphere doing to the plane? What's the mechanism there that makes the plane go one direction faster with the atmosphere and winds blowing in all different directions? The winds, you admitted, are the thing that pushes that plane. There's no air moving the plane other than the winds, right?
Yes.
So there's no air pushing the plane eastward faster to keep up with the Earth. The wind's going all directions. The winds aren't pushing him eastward.
So,
only.
But that on average, right, the air is moving with the Earth. So if you've got 100
back to the on average, the concept does not even, it's not even good enough, Daza. Even if on average, you can't say we're going to almost be in sync with the Earth when I land the plane. You know, it's perfect. All the variables would have to somehow beyond kinematics, somehow dynamically move it just the right amount so that the winds that are pushing it in the opposite direction aren't affecting it. I mean, there's all these different variables that you can just say the whole thing's moving at it. You know, we're going to have all the winds going in all these directions moving at the same pace as the Earth, and we're just going to pretend it's exactly the same, even though we say generally, which means it's not the same. And it wouldn't be anywhere near the same because it would only be maybe close to the same at the very, very surface. There's a loss of that as you go up. We have that drag that would only work very, very minimally. And you're acting like the atmosphere as a whole is going to somehow make it go the opposite direction of the plane landing toward the west. You know, it doesn't. You realize it's just a concept. There's no forces you can name. The winds are the forces that on the plane. The air does not force the plane other than a wind. But you're acting like there's this force that's hidden somewhere that makes the plane in sync with 1,000-mile-an-hour rotation.
Okay, so
yeah,
let's go back to my little guy. He's ultralight, right?
No rebuttal.
What?
Just want to walk us through from step one to the very end again, as if I never said anything.
You don't actually ever say anything. The thing is here, right? So let's look at the little ultralight guy. He's sitting in his plane, and let's just because you can't.
What's the dynamic force that keeps the plane in sync as he's landing in the opposite direction? That's all I'm asking.
Air drag. Air
drag. Okay, that would be what? An air drag? What do you mean? You got winds going the opposite direction. No, so what's an air drag then? How do you calculate your air drag that makes it perfectly in sync backwards as he's dealing with winds that are pushing him in any possible way? The air drag is somehow going to average it out and make it all perfect. What? There's no force there. You're just saying air drag. There's no force. If it was air pushing the plane, the pilot would be aware of it, just like he is the winds. You can't be air drag that's just figured in. There's air drag or friction or whatever you want to call it, making it in perfect sync generally enough for the pilot to never worry about any of it. I mean, I'm not even entertaining that possibility any longer. You act like I'm not understanding something. Come on, dude. It's silly.
So on average, the air is moving with the Earth, and the difference from that average is what we know as wind, right? So would you agree with that? That on average,
we have winds going in all
according to the
directions.
globe model, right? According to the globe
model. But the wind's going all directions. So why if it's all based on this consistency of eastward direction, why would any inconsistency mean that's the wind?
He just doesn't know how to separate and tell us this difference between air and wind. If it's a speed at 1,000 kilometers an hour, 1,000 miles an hour at the equator, right? The air, which you're separating from the wind, is also moving that speed.
Yeah, that's what he has to think. He has to pretend it is, right? Because there's no force there. There's no proof of that. It's just like, let's just pretend it's all when there's no wind. That's when, the air is in perfect sync. The atmosphere is only in perfect sync when there's no wind, right? So then we can pretend that it's all moving in perfect sync at that time. But then there's winds. That's when it's not in sync. And those winds could be going in any direction, but it's only because it's not in sync eastward. And none of it works anyway. Even if you got all the way up to the point where the air is carrying the plane, now he's going to accelerate in the opposite direction to land the plane. And you got to pretend there's some kind of drag in the air, regardless of all these winds going opposite directions or whatever direction, and him slowing the plane down. You just pretend that it's still going along at 1,000 miles an hour with the ground so that the pilot cannot even worry about it. And generally, or more or less, moving with the Earth isn't even good enough. Like even if there was a force in there, which there isn't, besides the winds, right? Even if there was a force to carry the plane in perfect sync, it wouldn't be good enough because it's not in perfect sync. You say generally, as if that's good enough. When he's landing the plane, it has to be perfect. There can't be any estimation to that, and there never is because the Earth is stationary.
So just going back to the air motion with the Earth, would you agree that if we had you've probably done this in a backyard pool, you make a big whirlpool, right? And it's all spinning around. If you were to drop something in that whirlpool, it'll circulate with right? So
not at the same exact speed. There'd be variables involved even with that, like the blender scenario. You got all kinds of variables there. It's never perfect.
No, it's never perfect. So this is the notion we have with the Earth, that it's like the water in the whirlpool. It is spinning with the Earth, and you drop something in it, and you're attached to that flow. If you want to go,
but you agree that the pilot makes a perfect landing, right? The pilot makes a perfect landing without accounting for rotation of the Earth whatsoever. He may deal with winds, right? But he makes a perfect landing because he's correcting for winds, not for the drag that's moving him eastward faster.
Wow. You skipped over that new perspective. You just missed what he said. Like if you go against that whirlpool flow, he says you're not going to notice it. You're going to be swimming upstream, dude, if you go against that flow. What are you talking about?
Yeah, like if the Earth were only moving eastward and there was this wind that you had to always somehow contend with that moves eastward only, just the idea that the atmosphere as a whole or generally or more or less or whatever estimation word they want, the idea that the atmosphere is moving with the Earth in one direction, yet we have winds in all directions that the pilot dynamically, physically deals with, and he doesn't have to worry about this other thing that's making him go 1,000 miles an hour eastward without that changing his forward motion whatsoever. What about the vector addition again, by the way?
Sorry, I missed all of that. I wasn't listening.
You just said that just imagine you're in a swimming pool and there was a whirlpool and the water was all flowing around in one direction. Yeah. And you were saying that if you flow against it, you're not going to notice it.
No, I did not say that at all. So in the case of the whirlpool, the Earth is rotating with the whirlpool, right? So if you're just sitting there in the water going round and round and round, you don't have to do anything. But if you want to move towards the center of the whirlpool, you have to do a bit of work, or move from the outside to the center, you've got to do a bit of work. And
yeah, you would have a tangential velocity gradient to deal with. and you would have to deal with it because it would be real, not something we pretend is there without it, and just say it's perfect.
No,
even though we admit it's not perfect, but it's perfect.
If the outside of the swimming pool was moving the same speed as the whirlpool, it wouldn't make any difference. You'd still have to swim upstream.
If you wanted to go against the current.
It doesn't work to compare it to something we know has physical dynamic results, right? If it's a whirlpool, those are physical things that you could measure and actually have to deal with. And swimming against the whirlpool direction would take more effort, right? But it doesn't take more effort to fly one direction or the other on Earth, except for if we have jet streams or winds. It doesn't have anything to do with the Earth rotating with the atmosphere rotating with the Earth. If there was a tangential velocity gradient, it would screw everything up, which is all I've been saying from the very beginning. And you want to walk through it step by step as if there was something I didn't say.
So Good Vibes brought up a good scenario. So if the pool was rotating with the water, right? So at the very outside edge of the water, the pool and the water weren't moving compared to each other. Was that what you're describing, Good Vibes? Something like that?
Tangential speed will be different at the outside compared to the center of the vortex. Plus, you've got that depth as well. The altitude is going to be different.
Yeah. So if we consider the case where the pool, like Newton's bucket, where we've got the pool rotating and the water is static compared to the pool, but it's rotating for an external observer. If you're sitting in the water at the edge of that pool and you want to go 1 meter in relative to the pool in the anti-clockwise direction or 1 meter in the clockwise direction, the amount of work you've got to do is the same. You only have to move 1 meter through the water.
That's not the way whirlpools work. If you're going against the circulation, it takes more effort than to go with it.
No, only if you want to go against the circulation compared to an outside reference, right? So if you want to make ground...
No, physically you would have to exert more energy to go against the spin. If it's moving you like a whirlpool with a liquid scenario, which is a non sequitur anyway, because it's liquid compared to air.
Because it relates. So if you've got the pool, the outside edge of the pool or the bucket is spinning, and there's no motion there compared to between the water and the edge of the bucket, right? Because they're all spinning in sync, and the water it's not really a whirlpool. It's Newton's bucket. We'll talk about, make it a bit easier. So all of the water compared to itself is static, but from an outside observer, it looks like it's rotating. If you're in that water and you want to go along the edge of the bucket, 1 meter in the anti-clockwise direction, or 1 meter along the bucket in the clockwise direction, you don't have to do any different work. Even though from the outside, it looks like you're moving further or faster, within that bucket, you only have to swim against 1 meter of water in one direction or 1 meter of water in the other direction, because it is moving with the bucket, right? So you're making ground relative to the bucket. The fact that you're rotating makes no difference.
You're trying to relative reference frame your way out of this. I don't know if you believe it or not, or you're just trying to argue it or what. But, I mean, if you have the air current, like a current, you're talking about a whirlpool, which is the current, the flow of the current of the water, right? And the current in air is called the wind, right? The wind current. Those are the physical things that have to blow. We don't have the same scenario. We don't have. That's a whole. Why would you bring up Newton's bucket as a fucking baller?
Because
that proves the absolute reference frame.
No, because in the Newton's bucket, the water is rotating in the bucket frame, right? So I mean, it's stationary in the bucket frame, but rotating from the outside. So
it's such a non sequitur because the water flowing physically in one direction isn't what we have. We don't have the air flowing in one direction. We have the air flowing in all directions. That's winds.
But
we do not have any kind of air movement going eastward, and saying on average doesn't make it any more true. And on average isn't even good enough. You can't just say, I'm going to take an average of where I should land, and hopefully I'll be in the middle of the runway.
I can separate the difference between water and air, but I don't think he can separate the difference between wind and air.
Well, he has to think of it as working in two different ways without it making any difference on the pilot.
Wind and air are the same thing, though. Wind and air is just one thing.
Exactly, I agree. The only force of air that moves the plane is wind.
It'll drop anyway.
You have to pretend there's this other force that's moving it along somehow in sync, almost in sync, or generally, or thought of as, or more or less, or any of these kind of on average ideas that's not even true. I mean, there'd be ways to know that for sure. One of them is we test it every day when a pilot treats the Earth as stationary without any concern whatsoever to this tangential velocity gradient of 0 to 1,000 miles an hour, no matter how gradual you want to think of it, no matter how in sync, more or less, you want to pretend it is. It wouldn't even be good enough with all of those little caveats, all those little, those not caveats, with all those little excuses that you like to pretend. He's correcting for a ground path. So it's the pilot making it go faster eastward. No. If he doesn't have a ground path, we'll just think about it as the air moving them then. It's like they always have to jump onto the next thing that could possibly explain it when they try to explain it as literally one way. And then that gets taken away with the ground path because it's a joyriding pilot. And then they have to say, oh, it's the atmosphere. But oh, wait, the reason it was moving to begin with the Earth is because it was on the Earth. So we had to conserve momentum, and now that we can't use that anymore, we'll use the ground path. And if we can't use the ground path, we'll just pretend the air moves it generally at the same pace, even though winds are physically, dynamically moving it all over the place. It kills the ball. There's no answer for that. Never have been. Been through it with Daza many times, and it's the same thing. He acts like he's just teaching a class, and somehow, because he explains it again the same exact way, that someone will understand that it could work kinematically without any dynamics whatsoever or any kind of forces whatsoever, just automatically in sync because of a kinematic concept where we're just going to do the right math to make it seem like it doesn't even matter. Hey, I just popped back in. Hey, just wanted to say I got to go, but no, nice job, Carlos. Yeah, you were right about that for sure. It would definitely be different with a whirlpool compared to the air, the wind speed going one direction and all that. But yeah, carry on with some new topic.
Yeah, he just has to throw in reference frames into everything. It's not about reference frames. You're either swimming upstream or you're not.
Yeah, exactly. I thought of something to send you, Carlos, to check your DMs, but it was in reference to a conversation that you were having. I'll have to remember what it was. But I thought to DM, just check your DM.
I know it was iridology.
No, oh no, I posted you talking about that. That was nice. A little short snippet. That's a fascinating thing. I'll have to look more into that.
I know, isn't it amazing how how like the zodiac is able to be observed in someone's eye? It's like that doesn't sound like it comes from a Big Bang theory to me.
What's the theory behind it? I mean, regardless of the associations that you can make with that or the correlations, what do they think causes that? The eye will show you that.
It's like your organs. Like your organs also are represented by time and the connection with the heavens and the celestial bodies. Like the time of day for your liver to be replenishing is like 4 a.m. in the morning, right? And then this 4 a.m. in the morning, if you look through astrology, you can have some correlation there with the celestial bodies too, and the time of year, and they're all associated. Like your body is a microcosm of the entire place that we live, of the realm, right? It's a fractal.
It sounds so far out there, but I totally think it makes sense at the same time because the microcosm of the eye showing you all the different possible ailments that the person's having and manifest somehow.
Yeah, it's like you can heal the whole body by doing nose acupuncture. There's also air acupuncture. You can do your ear, and you've got every point for your entire body for acupuncture all on your ear. You don't need to put needles all over your body. You can just do it on one place, like your ear or your nose. And like science doesn't. Like science used to say acupuncture is woo woo, but now you look how many acupuncturists are out there doing good work.
Yeah, and you've grown up around this, from what I remember. You said your dad was kind of a healer, or had kind of he was on a different level with that kind of supernatural.
My dad was a Qigong master, and he was a kahuna shaman trained in Hawaii. He's also an osteopath, distant healer. And my family, myself, I studied Chinese medicine. My brother got a Chinese medicine doctorate. He's a Chinese doctor. So I've been around it. I went to all of his classes for free.
Wow.
Yeah, there's definitely more to this world than a Big Bang can ever explain.
Or any kind of reference frames. Yeah, the reference frame idea is just it makes you relatively retarded sounding. It just does.
It's just all of these ad hoc, post hoc solutions for their model to try and explain how it would work, and you don't need to explain any of that. You just say, well, it's flat and stationary, and that's how it would act.
The only way to do it, though, you have to give them that. I don't know how else you would do it except for try to finagle it with reference frames. I mean, the thing is, the reference frames are very real. And the plane, even though the plane's moving over a stationary Earth, it's in a different reference frame. So it's not like we're saying reference frames don't exist, which is what they like to say, we think. No, it's just that there's no reference frame that explains this motion of Earth that could actually be justified and shown dynamics in any sort of way.
If you were put into a whirlpool, would you be able to know if the water was moving or not?
For sure. You would be spinning around in it, right?
And you wouldn't care if the outside of the swimming pool was said to be moving either. Like if it was moving or if it wasn't moving, what would be the difference? You're not touching the outside of the swimming pool to know that. You're just in the vortex itself, swimming upstream. You're going to know it.
Yeah, because they can get away mentally, I think, with the idea that there's no acceleration change, and so you would only feel acceleration. And but there is an acceleration change from 0 to 1,000 miles an hour with this tangential velocity gradient concerning airplanes or anything. It goes from one point to another. and they have to get around that somehow, and they can't do it. They can just pretend that it doesn't matter and that we're going to think of the air as perfectly in lockstep, even though we admit it's not perfectly in lockstep. And even if it was, there would be a force of that air moving the plane physically and accelerating it, which would be not only noticeable and felt, but something that he would have to deal with. And not only that, it would make everything not work at all, because point to point, it's just a stationary Earth that they fly over. They're never going to change.
Yeah, well, they always go into the idea that, oh well, it's relative. It's like, how long does it take for the Earth to rotate 360 degrees? It takes 24 hours, so it's not actually moving that fast if you think about it. But fuck, man, when they say 1,000 miles an hour, they're talking ground speed. That's 400 meters a second ground speed.
Right. And then use other tricks, like for newcomers especially. Like, it would be twice as slow as the hour hand of a clock. Yeah, if the Earth were the size of a clock, but if you got the hour hand going all the way out to the edge of the diameter of the Earth that they claim, the tip of that hour hand would be moving at literally 1,000 miles an hour. Just because you think of it as a clock and say it's twice as slow, we know that hour hand is not moving 1,000 miles an hour. You can't just trick your side. Do they really trick themselves into believing it, or are they trying to trick us? That's what keeps me interested in even talking to these guys, to try to figure out if they actually believe it. And then it's like, wait, then I'm accusing them of having no common sense. And I don't know which is worse, that they're just trying to argue that side for the sake of argument, or they actually believe it. I think it's worse if they actually believe it, instead of just playing the part of somebody that believes it.
Yeah, they actually believe it. That's the only way. They have to. They're fully indoctrinated. There's no way out.
Wow. But there's like dynamics, and these guys are talking about physics, because that physics are physical, right? The dynamics are the physics. You can't just like say kinematics are the same thing, right? Or the geometry, all of this is just, there's categories, right? The dynamics, the physics. That's where the real physics is, the physical physics. Not just some math thing that you add in there to pretend that it doesn't matter physically. But yeah, we've had the best test to see if the Earth is rotating with planes ever since, the inception of planes.
If they do have satellites up there, like you said, in the way, like through these magnetic, like electromagnetic fields, like is it possible then that the ISS could have people up on there just flying around, like with this idea that there's like this field that they're able to sort of hitchhike on?
I guess it wouldn't be impossible for people to be on something that's actually rotating up there, for sure.
But if
I don't know about the speed, 1,700 miles an hour.
It must be like really hard on the body. Yeah, because like otherwise, why would they have to be? Why would they have to be faking it all the time then? I guess like they probably could be up there if that is the case, but they wouldn't be able to stay up there for extended amounts of time.
No.
Yeah.
Again, just assuming that it's like this rotation that doesn't matter because it's consistent, and it could be, what is it, 1,700? So that'd be, and they say that speed of sound 7. What is it? A bullet travels how fast, right? I mean, it's just like so many different, so many times the amount that we know physically is safe for us to move at. Maybe with the airplane going, I don't know. There's jets too, that go 1,000 miles an hour, 2,000 miles an hour. You'd have ways of getting out of sync with the Earth, because even if you were moving with the atmosphere that's more or less moving with the Earth, you'd be able to put a camera out the window and show that the Earth has a different acceleration eastward than your plane is going with the Earth, because the atmosphere is not said to be in sync. We would know for sure that the Earth is moving if it's moving, because of those things that would be variables they could test for every day with an airplane, camera, or just landing it. That's why I go straight to landing it. You can't just like estimate he's going to be in sync with the runway that he's landing in. He has to be perfectly in sync and not have any of those variables be whatsoever a factor. And it would be not only a factor, but it would make it impossible. You'd have to fly the plane sideways or backwards to stay in sync, and then somehow there'd have to be a force in the air moving the plane backwards to stay perfectly in sync, even though the air is not said to be perfectly in sync. So it wouldn't even be good enough, even if there was a force there that was moving the plane backwards. So it kills it. Every single day that a pilot treats the Earth as stationary, it proves it's stationary. All of this is just, there's categories, right? The dynamics, the physics. That's where the real physics is, the physical physics. Not just some math thing that you add in there to pretend that it doesn't matter physically. But yeah, we've had the best test to see if the Earth is rotating with planes ever since, the inception of planes.
If they do have satellites up there, like you said, in the way, like through these magnetic, like electromagnetic fields, like Is it possible then that the ISS could have people up on there just flying around, like with this idea that there's like this field that they're able to sort of hitchhike on?
I guess it wouldn't be impossible for people to be on something that's actually rotating up there, for sure.
But if
I don't know about the
that is the
speed,
case, I
1,700 miles an
mean,
hour.
it must be like
You'd have
really
to deal with
hard
all
on
of
the
that.
body. Yeah, because
Yeah,
like
there's
otherwise,
all those
why would
things.
they have to be? Why would they have to be faking it all the time? Then I guess like they probably could be up there if that is the case, but they wouldn't be able to stay up there for extended amounts of time
No,
because like
no.
yeah.
Again, just assuming that it's like this rotation that doesn't matter because it's consistent and it could be, what is it, 1,700? So that'd be, and they say that speed of sound 7. What is it? A bullet travels how fast, right? I mean, it's just like so many different, so many times the amount that we know physically is safe for us to move at. Maybe with the airplane going, I don't know. There's jets too, that go 1,000 miles an hour, 2,000 miles an hour. You'd have ways of getting out of sync with the Earth because even if you were moving with the atmosphere that's more or less moving with the Earth, you'd be able to put a camera out the window and show that the Earth has a different acceleration eastward than your plane is going with the Earth because the atmosphere is not said to be in sync. We would know for sure that the Earth is moving if it's moving because of those things that would be variables they could test for every day with an airplane, camera, or just landing it. That's why I go just straight to landing it. He can't just like estimate he's going to be in sync with the runway that he's landing in. He has to be perfectly in sync and not have any of those variables be whatsoever a factor. And it would be not only a factor, but it would make it impossible. You'd have to fly the plane sideways or backwards to stay in sync, and then somehow there'd have to be a force in the air moving the plane backwards to stay perfectly in sync, even though the air is not said to be perfectly in sync. So it wouldn't even be good enough, even if there was a force there that was moving the plane backwards. So it kills it. Every single day that a pilot treats the Earth as stationary, it proves it's stationary.
About the sun and the moon, I think there is definitely a relationship with the between the sun and the moon itself, but like the way that they explain it is that the moon is continuously falling around the Earth in its orbit. It's like when it's on the different side of the Earth from the sun, like because there's a gravitational relationship between the Earth and the sun, right? So if it's affecting like the way that the Earth is sort of locked to the sun in this orbit, elliptical or not, that same force that is linked, like tethered between the Earth and the sun, why doesn't it affect the moon? Like it should like put the moon off its orbit. It should be out of balance. It should be wobbling. It should have flown away by now.
Regardless of that, the physics of it perpetually falling and staying, as an orbit doesn't even work. Michael Brenner does a great job of breaking that down. How it can't just be falling, with this gravity vector and this parabola around the Earth that never ends because of the sync of it has to be perfectly in sync. I've caught Daza on other occasions saying it just so happens to be so perfect. It just happens to be the exact right amount. He has to even go there with other things like gravity and the re-entry into the atmosphere and all that. But the funny thing is, I was going to tell you, Michael Brenner also says something about the way that if it was an ISS situation or the way that they depict in the movie 2001: A Space Odyssey with them always having to have those boots that are magnetically connected to the ground, and then when he goes into that thing where he's exercising and he's running, and that thing is rotating, and he's able to run sideways because the uh, the velocity outward, the centrifugal force would act like that. They would have to deal with the centrifugal force consistently on the ISS if it were actually doing what they say that it's doing. It would be more like that movie, is my point, or his point. And the thing I was going to send you, by the way, before I go real quick, is something about the video. Have you seen that? Have I sent you? Where Ewan's showing me all the satellites that he's tracking with his green, his night vision camera.
Yeah, I've seen one of them like that. That you were having a discussion with him. He was showing you and talking about like the satellites through his night vision, how they were able to be. Yeah, they were like going in different courses and stuff, and it just didn't make any sense.
Well, there's things flying around up there for sure, you know, and definitely it seems like we're deploying things up there. In fact, that's why they always have to do their launches for deploying satellites at the equator. I don't know. He's looked into it. He seems to be sure that there's difference as well in charge that it would take. It's all about the charge, whether it's in the north or the south. And if it's an electromagnetic field that they're using, that gives it a mechanism. And that's why they hate the dual pole with the two toroidal fields working as a mechanism. They have to go. They have to claim flat Earth has no mechanism, no idea how things could be working up there, or satellites could work over a stationary Earth. Well, if it's an electromagnetic field that you're utilizing, that gives it a mechanism. And if it's a certain charge that one hemisphere or one side of the Earth has compared to another, they would have to take into account for that. And yeah, he talks about the people that are actually, figuring out how it's going to be deployed and where and when would have to know these things, whether it's in the north or the south. The people that might just be on the lower ranks from that could just believe it's orbiting a ball Earth very well. They could be fooled into thinking that. Same with the GPS. I mean, it's set up so well that you might not know the difference, and you could just look at the diagram as a ball Earth. And even with going around the Earth on the water with a ship, if you're going around the North Pole, you wouldn't know necessarily if you're on a stationary Earth or a ball Earth. I mean, you would, because the ball Earth would have different dynamics, obviously. But as far as just your location and relation to the pole, the North or the South Pole, if that's the way it is, and the oceans are just surrounding everything, then you could totally believe you're on a ball Earth, as long as you don't think about the dynamics and all that. That would make everything different. Anyway, I should have gone already. I have to go because I have to go. But good talk, Carlos. So start up another conversation. Somebody, there's too many people in here.
Thanks, new perspective.
Yeah, there's a lot of people.
Absolutely.
Yeah, I mean, I'm just sort of preoccupied staring at the sky right now. There's so many what we call falling stars, and I can see what they call satellites just moving everywhere. And by the way, the day after tomorrow is the big day, apparently. The Seattle prediction, about that.
Oh yeah, that's right. You and I are some of the only ones in here that pay attention to Jurassic liars, or IPS stuff. But yeah, he's going to go. IPS is going to go there. He's going to be in Seattle
he's going to stay awake 24
the
hours.
grand event, right? I haven't looked at the collection of prediction programming except for the one from the last 6/11 that they were predicting it for. It's probably some of the same stuff. I don't know if there's been some this year that they're talking about. The whole idea, for anyone that doesn't know, is that there's supposed to be some kind of predictive programming telling us that there's going to be some kind of event happening involving the Space Needle, because of all of the times that they've shown the Space Needle having some kind of destruction or event happen in movies and ads or whatever.
And that's
And I don't know,
happening
6/11. Yeah, well, 6/11 is the date, so he's going to go up there on 6/11 and figures if he dies, it'll be worth it. Tsunami, maybe, I don't know. It's like all this focus on Seattle being a place that some event's going to start, and I mean, the guy's pretty brilliant in some ways, the Jurassic Liars guy, but he's always off, and he's always he's definitely wrong on a ton of things that I know about personally. I know he's wrong about a lot of things, but his methods are interesting just to entertain, to look at his reasoning on it. Some of it makes like a little bit of sense.
Maybe they like doing their terrorist attacks on the 11th day, like 9/11, 6/11, that sort of thing.
Well, it wouldn't be terrorists. I mean, you mean whoever the people are that are doing it, the terrorists. seem like the scapegoat more than anything. But I guess it would be a form of terrorism there who's doing it, and it's an esoteric interpretation of the numbers and all that. Anyway, I gotta go, guys. Talk to you soon.
Ciao.
Man, I love listening to that guy.
Because he makes sense, right? Everything falls into place when he talks.
Yep.